So you can start.
All right, sir. Okay. Good day. My name is Achal Imshmerim Eze, and I will be taking the defense session on XE105 defense real application as a cybersecurity analyst. Now, introduction. Why Python for cybersecurity? Cybersecurity analysts need automation to handle increasing, thre- increasing threats, hence the essence of Python. Python is an essential tool in cybersecurity because of its automation, versatility, simplicity, and vast library ecosystem. It is easy to learn, which makes it accessible for both beginners and experienced professionals. Python's extensive
Sorry,
libraries
just one
allow.
minute. Can you expand? You are not actually presenting. Can you? You are just scrolling down. Okay. Okay. You are using the web-based approach. Okay.
Yes,
I'm not
yes.
seeing the screen. Can you start all over, please?
All right, all right. So, good day. My name is Achal Imchimemeze, and I'll be taking you on the defense session XE105 defense real life application as a cybersecurity analyst. Introduction. Why Python for cybersecurity? Cybersecurity analysts need automation to handle increasing threats, hence the essence for Python. Python is an essential tool in cybersecurity because of its automation, versatility, simplicity, and vast library ecosystem. It is easy to learn, which makes it accessible for both beginners and experienced professionals. Python's extensive libraries allows cybersecurity experts to automate tasks, conduct penetration testing, and analyze malware, develop security tools quick and efficiently. Its strong community support and ability to integrate with other technologies makes it ideal choice for handling the evolving changes of cybersecurity in a fast-paced, threat-driven environment. Now, moving on to Lab 1, variables and data types. Variables are one of the fundamental building blocks of programming. A variable is a symbolic name that refers to a memory location where data is stored. It allows programmers to store, retrieve, and manipulate values efficiently. Assigning values to variables. The syntax for assigning values to variables is this: the variable name and then the value. As you can see from this code here, name is the variable name, while the value for this variable name is easy. Age is the variable name. The value for the variable is 19. And we called out the variables using this function here, print. So we print if my name is name, or calling this value here, name, and I'm age years old, which is calling this value here. And from the output, as you can see, my name is Easy, and I'm 19 years old. Use case, tracking login attempts. So we initialize the failed login counter, which is failed logins. That's the variable that we're going to be using. Failed logins is equal to 0. Then we open the file and count the failed login attempts. We use with open log.txt and we read the file as log file. Then we now use the for loop for I in log file. If failed password in I, we check for failed login attempts. Then failed login attempts is equals to failed logins plus 1. Remember, this is the variable that we initialized. So we're giving it the value of the count of the failed login attempts in this file. Then we check if the number of failed login attempts that we've assigned exceeds the threshold, which we now use this loop, this condition here. If failed logins is greater than 2, print alert imputes the values of the failed login attempts that we got and failed login attempts detected. And as you can see from the output here, alert 8145 failed login attempts detected. From the outputs, it is right to say that the high number of failed login attempts could indicate an ongoing brute force attack, where an attacker is attempting to guess a password by trying many combinations. This is a common tactic used to compromise accounts or systems. There are two basic functions. Built-in functions are predefined operations that come with Python by default, some of which are bind, split, board, char, sort, is alpha, reverse, and remove. These functions perform essential tasks like modifying strings, handling lists, processing numbers, and interacting with system resources. In cybersecurity, these two functions help automate data analysis, detect anomalies in logs, and validate user inputs. And we have an example here, authenticating user inputs. So we say user input is equal to admin123. If user input is alpha, so we are checking if this input here is just alphabets. That's what this is alpha does. So we say if user input is alpha, print valid input, else print invalid input detected. As you can see from the output, it says invalid input detected because this has alphabets and it has numbers. So it's not just alpha, so it is false, which is why we got invalid inputs detected. Another example is enforcing password policies. Password is equal to input, enter your password. So we're prompting the user to input a password for us, and you can see the password that the user inputted. Then we now say if password is lower, then print password cannot be empty, else print password meets basic security requirements. As you can see from here, it checks if the password is in lowercase, and it prints out password meets basic security requirements because it's not in lowercase. Now for the use case, normalizing security logs, the code, we use file path. We define the file path as the file that we're using. And then we open the file and read it. We said with open file path as file. For I in file, if field password in lower, print I.strip. This removes any white space dot upper, and it makes the outputs that we are getting, converts it from lowercase or from whatever case it is to uppercase. And as you can see, this is the output. Security logs often contain a mix of lowercase and uppercase, making it harder to search for specific patterns. Converting logs to uppercase ensures that search queries match regardless of the original format. Now, lab 3, slicing and casting. In cybersecurity, analyzing and processing textual data is crucial for detecting threats, passing logs, and extracting useful information from network traffic. Python's string slicing and indexing features enable efficient manipulation of text data, simplifying the automation of security tasks and extraction of relevant information. Now, for the example, we have extracting parts of a string and negative indexing. For extracting parts of a string, we have this string here, text is equal to cyberscript. Now, to extract a part of this string, we use print text index 2 so this is start and stop. So we start from index 2, and since there's no value here, it means continue on to the end. So as you can see, this is index 0, index 1, and index 2 here, B, which is why we have BER scripts. Another one we have is print text start. It doesn't tell us where to start from, but it shows us where to stop. So it starts from the beginning at index 0 and stops at index 4, which is why we have side. We now have another one, print text starts from index 4 and stop at index 9, which is why we have R space SCR. For negative indexing, we have here, using the same text cyberscript, print text negative, index negative 4, and that's from the back, from the end. So this is -1, -2, -3, and -4. So the print starts from -4 and goes on to the end. As you can see, it only says -4 here, which is why we have RIPT. Next, we have start and stop. We don't have anywhere we're starting from. We're just starting from the back to the end, which is why we have the entire script in reverse. So this is reversing the entire script. As you can see, it says cyberscript here, but here is TPIRCSREBYC. Then we have print text -5 and stop at -2, which is, it starts from index of -5 from the back. So this is -1, -2, -3, -4, -5. And then to stop at -2, this is -2 here. So it's CRIP. That's where to stop at. Now the use case, extracting timestamps for incident response and forensics. The code we'll be using is with open auth.log.txt as file. For line in file, timestamp is equal to line index, stop at index 19, print extracted timestamp, and then inputs the timestamp. And then this is the output that we have, the timestamp from the file. So timestamps are critical in digital forensics and incident response. They help security analysts to reconstruct the sequence of events leading to and following a security incident. Now, lab 4, loops. Loops are one of the most essential programming structures in Python. A loop is a control structure that repeats a block of code as long as a condition is met. Instead of writing repetitive code manually, loops allow a program to execute the same operation multiple times with minimal effort. Now we have an example with for loop, and we have an example with while loop. For the for loop, we have this: for I in range 1 to 11, print I. Normally, if you are not using this loop, you would do print 1, print 2, print 3, print 4, and doing that manually will take so much time. It's time consuming, which is why we use for loop. So we use for I in range 1 to 11, print I. As you can see here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now for the while loop, we use this: correct password is equals to secure 1, 2, 3. User input is equals to this. While user input is not equal to correct password, user input is equals to input enter password. So we're prompting the user to input a password, and we're going to compare the password the user inputs with the already stored password here, which is why we say use the while loop. While user input is not equal to correct password, user input is equal to input enter password. So when the user inputs a password, it compares it, and then if the password is the same, as you can see from here, is the same, it now prints out access granted. Now use case.
I'm sorry, just 1 minute. I'm not very satisfied with the use of your while loop. Can you bring it back again? Because it's actually
Yes,
not running through any. Can you explain the while loop one more time?
Okay, so as you can see here, we already have this user underscore input is equal to this. But if we are using while loop and it's saying while user input is not equal to correct password, user input is equal to input enter password. So what this means is this: while at this point here, before inputting any password, we already have a variable here, user input, and this variable here is not equal to this password. So it now says while that is not equal to this stored password already, you now compare with what the user now imputes, which is this password here, secure123. So it compares the imputed password that the user would put and not the variable here. That's why it says while user input is not equal to correct password, because at this point it's not equal to correct password. It's just empty. So it says while it is not equal to that, user input is equal to what the person would put in. So when the person puts it in and it's equal to it, then it prints access granted.
Okay, all right, that's fine. Let's move to let's see the use case.
Okay, now the use case: filtering log file, detecting number of failed password attempts. Now we use count is equal to 0. We open the file, we open auto.log, and we read it as file. Data is equal to file.read lines. We're reading through the file line by line. Now say for I in data, if failed password in I, we're checking for failed password if it is in this text while reading text line by line. If failed password in I, we're now counting it. Count is equal to count plus len string. And we have this here. That's the amount of times that failed password appeared. Now, lab 5, input and output. Input and output operations are fundamental to programming, allowing interactions with users, files, and systems. Input and output refers to process of receiving data inputs and displaying, storing, or transmitting data outputs. In a security context, inputs can come from users, log files, network packets, or system processes, while outputs can be logs, alerts, reports, or modified files. Now, we have an example here. Username is equals to input enter username dot strip. So what this line means is that it's trying to, we're prompting the user to enter their username, and we're using this dot strip to remove any space at the end. So we say username is enter username and print it, and then the person imputes Dave123. And now say if username is unknown, print welcome, else print invalid username format, meaning that the username is supposed to have numbers and alphabets, which is why we say is unknown. So it checks if the input of the user is alphabets and numbers, which is alphabet and numbers you can see here. So it prints out welcome Dave123. This method unknown checks if a string consists of only letters A to Z in capital letters or A to Z in small letters, and numbers 0 to 9. It returns true if all characters are alphanumeric and false if there are any special characters, spaces, or symbols, which is why we use the split, the strip here, the strip.
Okay,
Now,
let me see your use case.
Extracting IP address with failed login attempts. We have source IP is equal to this empty list here. We say with open auth.log.txt, we read the file as file. Data is equal to file.readlines, or reading through the file line by line. And we say for I in data, if failed password in I, content.split, we're now converting it to a list. As the IP is equal to content index 4, source IP.append. So we're now adding the value that we've gotten to this that we created here. Print source IP, and you can see from the output, this is the output that we got.
Sorry, let me see your output.
All right, sir.
Okay, all right, that's fine. Let's move on.
All right, sir. Now, lab 6, modules. In Python, modules are files that contain reusable code that can be imported and used in your programs. Python provides several built-in modules that allow you to interact with operating system, some of which are OS, sys, random, time, string. And we'll have example. For the OS module provides a way to interact with the operating system. It allows you to work with files, directories, and other system level operations. For example, we have os.get current working directory and os.list directory. As you can see, os.get current working directory, what it does is that it prints out the current working directory that you're in. And os.list directory, it gets out all the files and gets out all the contents inside the directory. As you can see from the output here, we did import OS, we're using the OS module, and then print current working directory, then os.get current working directory. Now, current working directory is home Kali. Then we now did print files in current working directory, os.list dir. As you can see, these are all of them. And we now have the sys module. The sys module provides access to system-specific parameters and functions. For example, we have sys.version and sys.platform. We use the import sys to use the sys module. Then we do print Python version, and we use sys.version to get the output. As you can see, Python version is 3.12.7, May November 8, 2024. Then we now have print operating system. Now use sys.platform. Operating system is Linux. Then we have the random and the string module. The random module provides functions for generating random numbers, selecting random elements from a sequence, and shuffling data. So we use the import random to use the random module. When I say print random integer, random.randint 1 to 10. So it chooses a random integer from this range that we've given it, and it gave us 6. And then for choices is equal to apple, banana, cherry. So it says print random choice, random.choice. So it's choosing a random output from this list, apple, banana, and cherry. And random choice, it gave us apple. Then we now did random.shuffle choices, print shuffled list choices. And the shuffled list, so it shuffled this list here. And it now rearranges and gave us this cherry, banana, apple. But it was apple, banana, and cherry here. And for the string module contains useful constants and functions for string manipulation. For example, we now use import string. And to print ASCII letters, string.ASCII letters, and it prints all the ASCII letters, A, B, C, D, E, F, G to Z. And then we now have print digits, string.digits, digits is 0 to 9. Print punctuation characters, it gives us all the punctuation characters. Car is equal to 5. Print F is car a digit, car in string.digits. So it checks if this car is given here, which is 5, checks if it is in digits, which is why it said car in string digits. And it says, is 5 a digit? Answer yes, it's true. Now the use case, secure password generation. Using the random and string module, we use import random, import string. And then we now define generate password using the length. The range, it has to be 12 characters. 12, that's the length for the password that is going to generate. So when I did characters is equal to string.ASCII letters plus string.digits plus string.punctuation. What this means is that the character of the password that is going to generate must have letters, numbers, and punctuations. So now that we've defined that, we now say the password is random.choice car, meaning that after the program has finished getting enough from each of these that we've given it up to 12, it then shuffles them. It then randomly picks from them and gives us a password. Then it shuffles the password to ensure that it will be hard for any other person to guess or to just figure out, which is why we use random.shuffle password, then return this join password. Password equals to password. Password equals to generate password 12. Print generated password, and generated password is this IK $F6 asterisk and this symbol KC. Now, functions. Functions are one of the fundamental building blocks of Python. A function is a self-contained block of code that performs a specific task instead of writing the same instruction multiple times. A function allows you to define a task once and execute it whenever needed. For example, we have finding the cube of a number. So we use define cube num. We defined it as return num times num times num. So what we do is this, print cube 7. Since we've already defined the number here as num times num times num, 7 takes the place of this number. And we now have 7 times 7 times 7, which is giving us the cube of 7, which is 3, 4, 3. A function that calculates the cube of the number can be defined once and used whenever necessary. Now, returning lists, tuples, and dictionary. Complex data structures like lists, tuples, and dictionaries allow functions to return structured data that can be iterated over or modified. Now, to return a list, when the function is to generate multiple separate values, a list can be used instead. As you can see here, we're now defining squares up to n. Return x plus times x for x in range 1, n plus 1. Print squares up to 5. So this 5 is taken in place of n here and being put into this operation here. So it's finding the squares of numbers from 1 up to 5. And we did plus 1 so that 5 will be included as well, else it will stop at 4. So as you can see, instead of giving it to us one by one in a straight line, it gives it to us in a list format, which have 1, 4, 9, 16, 25. Lists are useful when dealing with sequences of values that may need further modifications. Now, returning a dictionary. Dictionaries are ideal for returning structured key-valued data. From here, we can see define user profile, name, age, and city. Now, return name as name, age, city, and city. Now, these are these here that we've defined. The profile user profile is Alice, 30, and New York. Alice is taking the place of name, 30 is taking the place of age, and New York is taking the place of city. When we print it out, we can see that name, we have Alice, age, we have 30, city, we have the value as New York. Returning a tuple. Tuples, unlike lists, are immutable, meaning that their values cannot be changed after they are created. As you can see, we define min, max numbers, return min numbers, and return max numbers. So that's what min max does. It gives you the minimum, the lowest number, maximum, the highest number. So num is equals to 3719. Low, high is equals to min max num, which is min and max. Now print f lowest, low, highest, high. So low is taking the place of min, high is taking the place of max. And from this list, it iterates through and gives us the lowest number, which is 1 from the list. And the highest number from the list, as you can see, is 9, and gives us 9 as the highest. And lab 8, practice, interacting with directories using OS module. The OS module provides a traditional way to interact with Linux file systems for seamless directory navigation and manipulation. And we use the os.get current working directory to get the current directory that we're in. We use os.chdr to change directory. We can use it in this format, os.chdr, and then the directory you want to navigate to. Then we now use os.mkdir. This is used to make a directory. So we can use os.mkdir test directory to create a directory. Then we now print directory created, os.path exists test directory. So this checks if the directory that you just created is there, and it gives you an output true. os.rmdir is to remove the created directory. So you can do os.rmdir and impute the directory you want to remove. print directory created always of files, and then this gives you false because you just removed the directory. And listing files and directories. We use os.listdir. The os.listdir function returns a list of files and directories in a given path. This outputs all items within the specified directory. Reading file contents. We now use with open etc password, and then we now read it as file. Content is equals to file.readlines. For line in content, print line.strip by removing the extra spaces. And then we're now using R, as you can see here. We're using R, so this is the read mode, and we're using read lines as well. This reads the file into a list line by line, and the strip removes unnecessary new line characters. Lessons learned and cybersecurity industry applications. The lessons learned: Python enhances cybersecurity automation. Understanding logs helps detect cyber threats. Now, the cybersecurity industry application, we have SOC analysts to automate log analysis and threat detection. Penetration tester, automate reconnaissance and exploit scripts. Incident responder, automate evidence collection and malware analysis. Now, in conclusion, Python as a programming language empowers cybersecurity analysts. Continuous learning and skill development are key. Now, so this certification validates my proficiency in Python programming and demonstrates to employers that I have the skills to write and understand Python code. This is particularly valuable for entry-level positions like web developer, data analyst, or test automation engineer. So this is the certificate that I got at the end of the program, Python Fundamentals XE105. Thank you.
Okay, just 1 minute.
All right. So.
Okay, I've seen your presentation, but next time, maybe because you guys are still here, those are basic industry applications. Now, when you are doing your defense next week, the project defense next week, Saturday, you should actually ensure you actually bring in an industry solution. Those your stuffs are too basics. Those are things you could actually do with basic, how will I put it? Basic text manipulation. That is what we're using as loops. What we want to see are industry solutions. So bring up industry solutions that actually can be used in everyday cybersecurity environment. So we're going into the question and answer session. So I'll ask you 5 questions. Each of the questions carries what? 5 marks. How do you check the type of variable in a Python script or in a Python program?
Okay, I should demonstrate it or just explain?
No, you can explain. We don't have that time for demonstration.
All right. Okay, to find the variable type, we use the type function. So for example, you can have name is equal to, and then you could put a string there or whatever variable you want to use. Then you now do print type and then the variable name that you gave it. That gives you an output of the class of the variable that you're looking for.
What's the difference between break and continue in a loop?
In a loop, break and continue, the difference is this. In a loop, break terminates the code entirely when it reaches the condition. But continue, it skips when it reaches the condition and continues running the code to the end.
Okay, all right, that's fine. How do you get the last element of a list?
To get the last element of a list, from the variable name, on the list of the name of the list, let's say the list is called Kali. You use print Kali and then index -1. That gives you the last variable of a list.
How do you read a file line by line in a Python?
If you read a file line by line in a Python program, you have to use the read lines function.
The read lines function. Now, the last part, how do you handle exceptions in Python?
To handle exceptions in Python, you can use try and except. For example, in a situation you're doing 10 divided by 0, that will give you a 0 division error. So you use try and except 0 division error, print except 0 division error. And when you run the program for 10 divided by 0, instead of giving you an error message, it gives you just the print that you put there, except serial revision error.
Okay, all right, that's fine. This performance is actually good, but what we're expecting an industry solution. So, do you have any question for us?
Yes, when would be the deadline to submit the video?
The video, we can have Tuesday, Wednesday. You are collating your use case Monday, Tuesday. So by Wednesday, you start developing your project, industry relevant project. Oh,
All right.
at the end of the class on Tuesday, we look at the project where can break your group, your unit into two. We develop industry relevant project with the experience you currently have in Python. So if you don't have any question for, so Tuesday will be okay, but your project should have been submitted before end of Monday.
All right, sir. All right, sir. Thank you, sir.
Okay, all right, that's fine. So you can exit the platform.
All right, sir.
So let me put it on. Okay. So good day. My name is Tao Michael Oluwashinam. I'm a 300 level student currently doing my industrial training with Think Cyber Nigeria. So I'll be taking the course Python and all the labs treated during the course. So introduction, why Python for cybersecurity? Sorry. The increasing need for automation and scripting, cybersecurity is evolving rapidly, and the increasing complexity of cyber threats demand automation. Python allows cybersecurity analysts to automate routine tasks, detect and respond to threats faster, and ensure better analysis of logs, networks, and systems. So here is how Python helps in threat detection, response, and analysis. So in threat detection, Python helps to automate scanning and monitoring of networks for vulnerabilities. In response, Python rapidly reacts to it helps to rapidly react to the detected threats using Python scripts for alerts and reports. Then in analysis, process and analyze large volumes of data to identify potential security breaches or anomalies. So personal motivation. As a cybersecurity analyst, Python will enable me to efficiently detect threats, analyze security events, and automate repetitive tasks, improving overall system security. So I'll move into the labs. So lab one, we treated variables and data types. So the real world application, it is used for automating cybersecurity processes. And the use case I used here was IP address detection, automating the detection of malicious IP addresses in network logs. So there's a scenario here. Imagine I'm working as a cybersecurity analyst monitoring the company's network traffic. Every day I get a list of IPs that needs to be checked against a database of known malicious addresses to prevent data breaches. So yeah, the task is to automate the detection of malicious IPs from incoming network logs. So I'll be explaining the code here. The code here is to detect malicious IPs from incoming network logs. In the malicious IPs, I put just two random IP addresses. Then I put IP to check, the first one. Then I used an if statement to check if it's a malicious IP. So the result of the code here gave me malicious IP detected. So I'm moving to the second lab, which is basic functions. So for basic functions, the real world application here is log analysis for brute force attacks. And the use case here is brute force detection, analyzing authentication logs for repeated failed login attempts indicative of brute force attacks. So here's the scenario. As a SOC analyst, which is Security Operations Center, you regularly monitor authentication logs. By automating log analysis, you can detect brute force attempts early, stopping attackers from gaining unauthorized access. So the task here is to detect an alert on brute force login attempts. So as I created this, wrote a script. This is log data, then field login from this IP address and field login from this IP address. Then I just did brute force attempts, the length of the log data, then print total brute force attempt detected. Then it printed out total brute force attempt detected 2 because that's the length here. And I use the length function to get the length. So moving into the third lab, that's slicing and casting. So the real world application for slicing and casting here is extracting sensitive information from logs. And this is the use case. Extracting personal identifiable information, PII, passing system logs to identify and extract user information, e.g. credit card numbers or user IDs. So the scenario here is as a penetration tester, I need to automate the extraction of sensitive data from server logs to identify potential information leakage that could compromise the security of the company. So the task here is extract sensitive data from logs and identify potential leaks. So yeah, I just wrote a code here. Log entry equals to user 1234567 access the system. Then user underscore ID equals to log entry dot split. This is just to split the white space characters then one. Then print extracted user ID, then user ID. So it basically gave me the extracted user ID, which I inputted here, 1234567 as you can see in the result of the code here. So moving on to the fourth lab, which is loops. So the real world application for loops, port scanning and network security. So the use case here is for scanning open ports, automating port scans to check for open services on a network that could be vulnerable to attacks. The scenario here is, as a network security engineer, I perform regular vulnerability assessment by scanning open ports. Then the Python helps me automate these checks, saving time and allowing for better detection of exposed services. So yeah, I'm just performing a regular port scan on network devices. That's the task. So yeah, I just wrote a code. I imported sockets and I used a for loop. Then for port in range 20 to 25, that means it's going to check between port 20 to 25. Then I also used an if statement to print out the port if any port is open, and then I closed it. So basically, the result of the code just gave me only port 21 was open at that particular time. So this is the result here. Port 21 is open. So moving on to the fifth lab, which is IO, input and output. So the real world application is managing sensitive configuration files. Then the use case is handling sensitive credentials, automating secure reading and writing of credentials and configuration files. So the task here is securely manage configuration file contents. The scenario: as a web application administrator, I handle sensitive data like usernames, passwords, and API keys stored in configuration files. Then Python enables securing, handling, and logging of such data for administrative tasks. So yeah, I used bit open, then I wrote into this file config.txt using the W, that's right. Then I wrote this user equals to admin slash end password equals to secure password. Then I opened the file again in read mode, which is R. Then I used file.read and I printed it out. So it basically gave me the username, which is admin, and the password, which is secure password. Moving on to the next lab, which is modules. So the real world application here is automating system updates. Then the use case, patching and updating systems, automating system updates to ensure software vulnerabilities are patched quickly. So the task here is, sorry, okay, the task here is to ensure all systems are patched and up to date. So the scenario here is, as a system administrator, I'm responsible for keeping software up to date. Using Python, I can automate system updates to reduce human error and ensure consistent patching. So this is the modules here. I just printed updating system packages and I use OS or system to get update and get upgrade using sudo. So this is the results here. I'm responsible for system updates, so I just got the update of my own system. Moving to functions. Here, real world application is automating incident response. Then the use case is custom incident response to automating log collection and system analysis during security incidents. So the task here is to collect system logs for analysis after security incidents. Then scenario, during a suspected breach, you need to quickly collect system logs for investigation. Python allows you to automate log collection and analysis to speed up the response process. So yeah, I just used def collect logs, then I collected the log file, then I opened the log file in read mode, then I just used file.readline so I can read the file as a string, then return logs, then print collect logs, then auth.log. So this is the result of the code I wrote here. Then moving on to the last lab, which is practice. So for practice, is automated vulnerability scanning, performs vulnerability scans to detect potential security risk as a penetration tester. So the use case is conducting a vulnerability scan, then scanning, performing vulnerability scans to detect potential security risks. Then this is the task here, perform automated vulnerability scans on network devices. So yeah, I just performed a vulnerability scan on my own network device. Then I just used import OS, then print scanning network for vulnerabilities. Then using the OS system, I just used nmap, my iPhone SV, iPhone P, that's port 22, then 80, then my IP address. So it just gave me this. This is the result of the code. Then, so I move on to the lessons learned. Python's simplicity makes it an effective tool for cybersecurity. Automation can significantly improve response time to threats. Then cybersecurity industry application, SOC analysts penetration tester, that's automate reconnaissance, then an incident responder, automate evidence collection. Then my future learning part, to explore advanced topics such as machine learning or AI in cybersecurity and advanced network security. An appreciation goes to Think Cyber Team, Think Cyber Nigeria, and XE105 trainers for providing invaluable skills. So that's the last one, sir.
Okay, all right, that's fine. Let's move into the question and answer session. You
Okay.
answer 5 questions, then each of them actually takes um, okay, how do you use 5 marks? How do you split a string on white space character?
So I can split a string on white space characters by using the split function and the name of the string. So that way it will remove any white space characters that are actually in that string when I use the split function.
Is it split or strip?
Split.
Okay, all right, that's fine. How do you split a string on white space character? That's what I asked. Okay, what's the difference
Yes.
between break and continue in a loop?
Okay, so basically a break is used to exit or terminate the loop completely, while continue is used to skip the current iteration in that loop.
Okay, how do you check if a key exists in a dictionary?
I can check if a key exists in the dictionary by using the keys function. The keys and the name of the dictionary. It will basically check and run through the dictionary and give me if any key is in that dictionary.
How do you remove duplicates from a list?
I can remove duplicate from a list by using the set function. If I use the set function and the name of the dictionary, and the name of the list, sorry, it will basically remove
Sorry,
the duplicate from that list.
which function is that?
Set,
Set.
yes, set,
Oh,
then the name of the list.
can you spell this set you're talking about?
Just set, then bracket, name of the list.
Okay, all right, that's fine. What's the purpose of the pass statement?
So basically, the purpose of the pass statement is this like a placeholder where it allows for empty functions, empty classes, or empty loops without it giving syntax error or without it affecting the actual code.
Okay, all right, that's fine. That should be the number 5.
Yes, sir.
I'm totally satisfied with that. So this performance is way better than what you've done before. However, you just jumped into use case without explaining anything about. You jumped into use case without explaining anything about the content of the class. So normally, can you go back to lab 1?
Okay.
Can you go back to lab 1? So in variables, that should be variables.
Yes.
You're supposed to actually talk about variables. Do one example or 2 examples of variables. Write some stuff on it before you now move to use case. Do you get it
Mm.
clearly? So that
Yes,
should be
sir.
your standard. At this point in time, we're not supposed to be teaching you how to do presentation. You should have learned it. Now, anything you take, variables and data, there's nothing in this presentation telling us what variables are, what data types are. So you summarize it with 2 or 3 examples before you now move to use case. So you do not do that part for all your presentation.
Okay, sir.
So I think, do you have any questions for us? So you'll be broken down into 2 groups next week. So all these things you're doing is just scratching the surface. Now, the next week defense should be what? Real industry presentation. You come up with a solution, you actually test it on the surface, then you present it to us next week. So that shows moving from where you are to what real mastery. Do you have any question for us?
No, sir.
So that is why you see your presentation was too brief. I did mean there was this thing in it. How will I put it? Use cases. Sorry, explanation of what the content of what you're treating, the subject matter of what you're treating. It becomes more lengthened. It's too brief. You just move into use case. However, you're able to communicate that you understand the techniques and you understand what you're doing. So you can exit
Yes,
the
sir.
platform.
Okay, sir. Thank you, sir.
You can start.
Okay. So can you hear me?
I can hear you.
Okay. Good morning. My name is Achoyim Chidera, and
Your
today I'll
voice
be
is too low.
presenting.
Can you add more volume to your voice?
Can I?
Can you add more volume to your voice? It's too low.
Okay, so good morning. My name is Achoyim Chidera, and today I'll be presenting on the real life applications of Python in cybersecurity. So we'll explore how Python helps automate tasks and detect threats and analyze security incidents. All right, so let's begin. Firstly, um, cybersecurity professionals must work quickly to identify and respond to threats. And Python is widely used because it allows us to do things like automation, which is basically automating tasks for cybersecurity operations. It helps us in threat detections, which is detecting and responding to security incidents, and it also helps us in analysis, so analyzing threats and incidents data analyzing threats and incidents data efficiently. So Python helps analysts to in threat detection, incident responses, and data analysis. Now, next slide. The first thing that we learned in our labs was variables and data types. Now, Python variables and data types help us to store and manage critical security data. So in cybersecurity, we often deal with structured and unstructured data. Now, such as user credentials, things like user credentials, log files, network addresses, and all of them. We use variables to efficiently store and manipulate data, right? And we use different type of variables. So the data types, something I'm going to talk about now. Now, these define the types of value or variable, whose value a variable can store. Now, common data types include things like Boolean, strings, list, and all of that. In the example I gave here, content is the name of the variable I am creating, and this variable is a string. So content equal to I am him, right? So if you print type content, you can find the um data type of this variable that I had just created. Now, we're going to talk about the use case. So one use case for this variable and data types is detecting unauthorized USB devices. So sorry. So many companies restrict USB access to prevent data theft, and a Python script can compare newly collected devices with a list of approved devices. Now, if an unapproved device is detected, then alert is triggered and it's preventing unauthorized data transfer. To look at the syntax here. So firstly, we import OS and we create the variable like we talked about. We create the variable allowed devices. So these are basically devices that are allowed. And now we connected device. This is the list with a bunch of devices in it. And this is connected device, which is ESB this, right? So we also create an if condition. So if connected device is not in allowed devices, so if the connected device is not in here, then we say print alert unauthorized USB device detected, else we print the USB device is authorized. So if an unapproved device is detected, then an alert is triggered, which
Did you
prevents.
try this script? Did you try using this script? Did you
Yes, I
run
tried.
this script in
I was the one that
practical?
wrote it.
Okay, all right, that's fine.
I took a screenshot and I pasted it. I was the one that wrote it.
Okay, all right, that's fine.
Okay, so the next thing we're going to talk about is basic functions, right? So functions are essential in Python as they allow us to automate security tasks efficiently. Now, instead of writing the same code multiple times, we can define a function once and call it whenever it's needed. So the reason for this is because it's reusable, right? So function helps structure cybersecurity tools to do common tasks like scanning logs or detecting detecting threats, and it can be used across different scripts. It's also good for incident response. Now, the use case that we're going to talk about, basically detecting suspicious file downloads. Now, attackers often disguise malware as legitimate files. Now, a Python right here. Okay, so a Python function can scan system logs for file downloads for unapproved sources. Now, alerting security teams before any damage occurs. By using functions, we can make our script modular. which is easier to maintain and more efficient. If you look at the syntax here, we imported OS and created a variable. In this variable, there is a list with things like downloaded from trusted.com. All of this is to detect malware. So if we create a function, right, to detect suspicious download, which is the
Sorry,
name.
can you tell me more about that download logs?
Sorry, what did you say?
The download, or you say download from trustedfiles.com. I don't know file. I do what exactly are you trying to do?
We are trying to detect suspicious file downloads. This is just an example. If a file is downloaded and it comes in this form, right? This is just a syntax to like create a scenario in order to explain it. If the file includes the text like downloaded from trustedfile.com, this is an example, or it's an unknown site which includes a malware. These two are a list. These are a list of things that it could come in. It could be many other things. It could be downloaded from
Did you
Net99.
run this particular script? Because if I
Sir?
get what you're trying to do, if you get what you are trying to do, you want to compare a list of sites. Now,
Yes.
if you are accessing a new site and it's not in that particular site, then it should tell you that you suspected download bugs, Abi.
Yes.
Maybe I'm not getting what you're saying. Or you have a list of what malicious sites, and anytime you are trying to, because what you are saying, I'm not getting it clearly.
What I'm saying is that if the site is known, right? If like this what's it called? This script is basically just to like show what something like this is supposed to look like. Obviously, there is no um site called trusted.com or unknownsite.com. But like in this
Okay,
scenario,
you're actually here to learn and train. What you have in the industry is this.
yes,
While I see the concept of what you are trying to do, there is a collation of malicious sites with their IP address. So anytime you want to visit those sites, it runs through a database of those particular collation. It blocks you from going there. It sets malicious sites.
okay, sir.
That is how the industry works. That is how the file works.
Okay,
And
sir.
people actually collate and send that this particular site is malicious, this particular site is malicious. So as you want to visit the site, always there is what? A destination IP address. Once it has it in its log, it tells you this particular site is actually what? Malicious. Don't visit it.
Yes, sir.
All right, so this use case you're saying, I'm not actually saying what, because it has to log through, it has to look through a database for it to be able to make a decision that what. So if you tell me with open, you have the file somewhere, you understand,
Yes.
or maybe you're trying to connect to the API. Whatever you're trying to do, in as much how basic it is, it should actually show a line of sight in what's actually being used currently in the industry. Now, in
Okay,
the
sir.
industry, there is what we call what? virustotal.com. So they have API. So as you're trying to connect, it connects and shows you what? List of what? Database of what they have to actually be malicious sites or malicious what? Signatures. Do you get it? So what you're
Yes,
doing
sir.
here is not for fun. It has to align with industry standard. So
Okay, sir.
anytime you are visiting a malicious site, it tells you clearly this particular site is malicious.
Yes, sir.
Do you
So the
get it
script is
clearly?
supposed to
Good.
detect it from
Now,
a
so
database.
there are sites who collect database of malicious what. So if you are feeding from those sites, you
Yes.
understand, and you write a script to connect to that site and compare what you did and comes back to you to actually what them, you will need an API or an integration to do that. Or maybe you have a database of malicious sites, then you want to open that database and compare. If so and so in this database, then print what? Suspected malicious site. Else, site is, are you getting it? So
I
it
understand,
makes
sir.
more sense that way than what you're doing.
I understand. So instead of a list of names here, it should supposed to be collecting information from a database
You
to
should have a
cross-check it.
database of malicious sites. Now, the
Yes, sir.
database of the malicious site definitely will translate to IP addresses. The domain name you
Okay.
see, From DNS, it becomes an IP address. So anytime you are going anywhere, you are only pointing to a destination IP address. So once the destination IP address is in that database list of what malicious sites, it tells you that that site is what malicious.
Okay, sir.
You get it clearly?
Yes, sir.
That's what's applicable in the industry. You can move to the next slide.
Okay. The next slide, we're talking about slicing and casting. So in cybersecurity, we often need to analyze raw data to extract specific pieces of information. And Python slicing and casting capabilities allow us to retrieve and process really relevant data efficiently. So slicing, this is basically a technique that lets us extract a portion of a string, such as an IP address or a file name or a system. And then casting, it basically just allows us to convert data from one type to another, such as changing a string representation of a number into an integer, right? So we're going to talk about, okay, for example, in this script that I wrote here, name is a variable, and right here is the variable is equal to a string chidera. So if I print name and then I slice it 3, this is where it's supposed to start. And because I did not put anything at the end, it would basically just run to the bottom. So it will start from 3, right? And the name chidera this is 0, 1, 2, 3. So it will start from 3 and run to the end. And that's why the result here is this. So we're going to move to the use case, right? So extracting suspicious file names from logs. If an attacker downloads malware onto a system, security analysts must identify the exact file name. So using Python, we can search logs for entries containing download and extract the file names associated with them. So this helps security teams quickly investigate and mitigate threats. So
how did you know that file is malicious?
How would I know?
How did you know that the file downloaded is malicious? You said if you download a malicious file, how is the Python detecting that the file is malicious? How are you detecting that the file is malicious?
We are checking for the file name.
No, file name cannot tell you that the file is malicious. Yeah, a file name cannot tell you that the file is malicious. Do you get it clearly? You can understand now, for future purpose, when you're doing a use case, do a use case that is real, not fictitious. All this you are doing, you are just only demonstrating how to split a file. You are not actually doing any use case. That's what you are demonstrating here. Now, every particular virus has a signature. The signature based, you understand, antivirus, they call them signature based antivirus. Do you get it clearly? So it's those signatures that they have in a database. So when you are downloading, so that signature of that database, if they have it, they'll tell you that this is a malicious file. That is how you know. So if you are telling me that you have a database of malicious signatures of AVs, viruses, now as you are downloading the file, it is actually telling you, it's comparing and telling you this particular signature is in this file. Hence, it's a suspected virus. So you can quarantine it somewhere else. Do you get it clearly?
Okay.
Why we are telling you all so that you don't open your mouth and say what you don't know in the public. Do you get it clearly? Now, you've done 2 use cases. The first use case is how to actually detect suspicious websites. Now, you are talking about malicious file. A malicious file is simply, or whatsoever, your next training, you'll be taking Trojan and malware or payloads. Now, how you know it has a signature. Sites collect signatures of malware. Now, when you are downloading, they compare, like you actually do your in your hashing. How do you actually decode hashing it? It's based on the database that the site has. So if it has the hash of the plain text you put in, it tell you this is there. Likewise, malware. So site stores malware. That is why different antivirus companies send their database to some site. So they compare it with it. it shows you what? Malware. Do you get it? Signature-based, at least for now. Let's leave it as signature-based malware.
Okay.
Do you get it clearly?
That's
Good.
all.
So all you're just demonstrating it here is not a use case. It's simply what? You are splitting a log entry. So you can move on. You can move on to the next lab.
Okay, sir. All right. So we are moving on to loops. All right. Loops help us automate repetitive security tasks such as scanning networks, processing logs, and monitoring system activities. In cybersecurity, automation saves time as it improves efficiency. Now, for loops basically allow us to iterate over a list of logs, checking multiple entries for a security. In the example I give here, name is equal to I am that guy. So for I in name, it's supposed to iterate through everything here and to print everything, including all the spaces. Now we're moving to use cases. The use case. So our use case is monitoring USB device connection. So attackers may repeatedly connect unauthorized USB devices to bypass security policies. Now, a Python loop can continuously monitor USB connection logs and raise an alert when an unknown device is detected. So by automating this process, security teams can ensure that
But you've
unauthorized
used,
devices.
I'm sure you used something like this in your first, this use case, this USB use case, you used this one in your first lab.
So what did you say?
This USB inserting, and you use it in your first lab.
I didn't get this from our lab.
Hmm?
I didn't get it from our lab.
This USB use case that you are saying, you use it in one of the lab. I've seen about that. I asked you that did you test this script? You said yes, you wrote it yourself and you took the screenshot. That was what you told me just now. Now, my point is this. The market is actually not in demand of an average student.
Of
An average student or an average talent. The market is not demanding. Anytime they call for an interview, they want to choose the best guy.
yes.
So you build yourself to be the best guy. Now, at this stage, you see all these small, all these basics, I am that guy. Grow up and start using real cybersecurity stuff. You understand? Scanning a network, scanning an IP address, scanning all those stuffs. They were actually in all the stuffs you did. There were more better use cases in your PDFs you could have adopted than what you're showing here.
I thought you said we shouldn't get it from the PDF.
No, you can adopt and develop something else from there. This USB, you are using it twice. Do you get it? Good. You can move on to something else. Let's say. So you see that it's not that you don't have the knowledge. Now, application of the knowledge. Let's see how we can practically apply it within the cybersecurity environment. That is what we want to know. So we've left the stage of mastering the basics of Python. Now let's move into everyday professional application. Can you move to the next lab?
Yeah, this is the next lab. So in lab 5, we talked about the input and output. So securely handling input and output operations is critical in cybersecurity. Python allows us to read and write data safely, which ensures sensitive information is not exposed. So reading logs, we analyze the data that is in the files that are needed, right? So we can, okay, whenever we want to read a file, we use R, and whenever we want to write a file, we use W, right? And reading logs, basically, security analysts often need to read and analyze logs for security purposes. And we also need to write logs because automated security tools generate logs to record incidents for future reviews. Now, we're going to talk about the use case. So, logging unauthorized firewall access attempts. Now, when an authorized IP tries to access a firewall protected system, so Python can log the event in a file for later investigation, which basically enables analysts to track repeated attempts and adjust firewall rules accordingly. Now, the syntax that we're using here is unauthorized IP equal to this is the an IP address that isn't authorized. So with open firewall, this is in this scenario, firewall underscore log is a file on its own, and we're trying to open it. That's what the input or output is basically talking about, accessing files. So in this scenario, we're basically trying to find IP addresses that are trying to log in, right? So we use a, which is append. So as log file, right? So log file dot write f unauthorized access attempts from, this is the unauthorized IP here. We're calling this back here, right? And we move to the next line. So if we print alert unauthorized firewall access logged, then this is what it will print. So if this IP address is detected, then this would be printed. And that's what this use case is for. All right, moving on. Modules, right? The next
Sorry,
one
can
we're
you
talking
come
about,
back to that? Can you come back to that? Because I'm seeing what will be treated. Now, can you explain the concept of this your solution very well? No. Sorry, you actually,
I
are
can't hear
you
you. I can't hear you. So
logging
you're breaking.
now? If you say unauthorized, okay,
No, I didn't hear what you said.
somebody is trying to ping your firewall. So anytime it pings your firewall, the authentication actually logs that IP. Now, from that point, how do you move it from that point and actually append it as what? What makes you think is unauthorized IP? At what edge of the network that is accessing? You understand? That makes it unauthorized. You understand? So it all depends on the part of the network is accessing that makes it unauthorized. Somebody coming to view your demilitarized zone is not unauthorized. You understand? So can you hear me clearly now? Can you hear me clearly?
No, sir, you were breaking.
Hello, can you hear me?
Now I can hear you, but you were breaking before.
Okay, good. Now, when you say something is unauthorized, it's a what? It's a restricted part of a network. Now, in a network, we have the demilitarized zone. We have what the internal network. And the demilitarized zone, like if I go to Babcock University website and I'm browsing through the website, is it an unauthorized zone?
So I can't hear you. You're breaking.
If I get to Babcock University website and I'm browsing through the website, is it an unauthorized zone?
No, sir.
Okay,
No,
good.
sir.
Now, so when you say unauthorized IP, what exactly do you mean? And you are putting what an internal
So
IP here.
if we okay, if we've detected an IP before, right, and we know that this IP is trying to log into our website,
No, it's not logging into
and
your
obviously,
website. You understand? You're still making mistake. Now, your use case, there is an intent for what you're doing, but the way you're articulating your point is wrong. Now, somebody going to your website is not doing anything wrong. By going to browse your website, you put it there so that people can actually check the website. Now, if it's trying to connect to the admin portal, that is an unauthorized access.
yes.
Do you get it clearly? So you are
Yes,
not actually defining that here. So by saying firewall logs does not mean anything. So it's trying to connect to what the admin portal securely from a remote shell to actually act into the control panel of the website. That's unauthorized what? Access. Do you get it clearly? So that when you are communicating, people know you know what you're saying, not just what a lay conversation. Do you get it clearly? Somebody who goes to your university website is authorized to do that, to check what services you are doing, then he pays for those services. Yes or no? Now, if he's trying to now see how he's trying to attack their control panel from the back end, that is what unauthorized. Do you get it clearly?
I understand.
Okay, good.
I understand,
So
sir.
that's it. So if you look at it very well, you see that what you wrote here does not really portray the right information. Do you get it clearly? Good. So that's it. You can move on to the next lab.
Yes, sir. Should I continue?
Yeah, you can move on to the next lab.
Okay. In the next lab, we talked about modules. So Python modules basically expand its capabilities by making it a powerful tool for cybersecurity. So Python includes modules like OS for system commands and sys for system level interactions. And there are third-party modules, which are basically libraries such as psutil, like that we use in this use case. And then we basically help monitor network security. So that's basically what modules are. So in order to use a module, you have to import it, and you say things like import OS or import sys or import anything, including PSU2. Now, for the use case that we're going to talk about is detecting suspicious network traffic. So by using the PSU2 module, cybersecurity teams can monitor unusual spikes in network traffic, which may indicate a data breach or attack in progress. So Python modules allow us to build advanced security tools with minimal effort. In this syntax right here, we import PSU2, which is the module we're using, and we create net usage equal to psu2.netiu.counter. This is the function. So if net underscore usage dot bytes sent is greater than 1 million, or net usage dot bytes recovered is greater than 1 million, then received is greater than 1 million, then we print alert unusual network traffic detected. Now the result here is unusual network traffic detected. So basically what this does is it indicates the data
I
breach.
know what it does. I think this looks more like something that is real. So this shows it is just a spike in traffic. It might be DDoS, it might be different. So this actually looks good. Can we move to the next?
Okay, so custom functions. All right, so custom functions allow us to build tailored security solutions, and functions can automate the collection of logs and generate security reports. Right, a function can also scan files and for known malware signatures. Now, in order to create a function, we use def and then put the name of the function and then put the parameter, and then we say whatever we want to under that, right? Like in this syntax, this is def, and this is the name of the function and the parameter. So, sorry. So in the use case that we are going to consider, we are considering automating malware log analysis, right? So security teams must quickly analyze large volumes of malware logs to detect threats. So Python functions can help automate this process, basically filtering out critical details for further analysis, which reduces the response time and enhances efficiency. Now we are creating a function, def, which is analyze manual logs, because that's what we're trying to do, and this is the parameter here. So with open log file, this is right here, R as file. Log equals file.read lines. This is, we are basically just trying to read the lines in there. And then the manual log is equal to log for log. And this is basically like a loop. So this is to count for log for log and logs if malware and logs. So we return manual logs. And this is basically just going to help us automate malware log analysis and basically analyze large volumes of malware logs to detect threats.
Okay. I think the problem. Can we just Is this on another use case?
This was part of the parameters that he sent us. He told us to talk about vulnerability scans.
Because how do you scan for vulnerability? You understand? Because I hope at least by now you start understanding how the scripts they work. Before anything can tell you this is a vulnerability, it's comparing it with a database that
Yes,
it
sir.
has. You understand?
Yes, sir.
Even the AI AI works with a database. I hope you get it. The artificial intelligence, it works with a database. The experience of database it has, that is what it's used to train. But the frequency at it actually does those analyses is way, way faster, like the speed of light. Now, if you have to actually, it's because we don't have time anymore. There is a class where you take all these vulnerability scanner, you write it and you understand how it works. Do you get it? So you must have a vulnerability data. Do you get it somewhere? You must have a vulnerability data that you input. Now, the only way you can know that something is actually vulnerable is you are scanning this particular target, and you are now seeing a vulnerability. You now compare it with the database of the vulnerability you have. It will now tell you this particular stuff is vulnerable and is in this machine.
Okay.
Do you get it clearly? So that's it. That's how it works. Now, you can scan something. If it doesn't have what a particular data is comparing what it's saying, it cannot give you any decision. So if it's a common vulnerability and if you have a list of what CV database, so as it's scanning it, it's comparing with those list of CV database it has. It cannot tell you, oh, this particular stuff is actually vulnerable and this is the score. It is very high. You must take action immediately.
Yes, sir.
Do you get it clearly? Good. You can move on to the next part.
Lesson learned and challenges faced. So challenges that we call this debugging errors, with basically encountering syntax and logic errors while implementing functions or modules, handling data sets, script optimization, and the things that we've learned is basically automation improves efficiency. So the whole reason for Python is for automation in order to increase efficiency. So automating routine cybersecurity tasks like log analysis and vulnerability scanning saves us time and reduces human error. So Python is a powerful tool for cybersecurity. Python's versatility allows us to seamlessly integrate into various cybersecurity domains, from network analysis to system management. Now we're going to talk about the industry application of the things that we learned in Python. So we can use Python as an SOC analyst, right? So we use Python for automating log analysis, monitoring network traffic, and detecting potential threats. Example, automating the passing of large log files to identify unusual behavior and flag suspicious IP addresses. We can use it as a penetration tester, which will help us leverage Python for reconnaissance, vulnerability scanning, and exploit automation. So an example of this is using Python to automate Nmap scans, like I did for port scanning and service detection on target networks. Now, incident responders is also use Python. So we use it to automate collection of logs, evidence, and malware analysis to respond quickly to incidents. And an example of this is automating the extraction of system logs after a security breach for a quick investigation. Now, in conclusion and future learning part. So the summary of Python skills learned. Basically, we automated cybersecurity tasks such as log analysis and vulnerability scanning and gained experience in Python modules, which are custom functions, loops, input, outputs, handling for security applications. These are basically the things that we've learned in conclusion. Now, the plans to explore advanced topics. So things like machine learning and AI cybersecurity, this is basically exploring how machine learning can predict and identify threats in real time. Now, advanced Python libraries. So diving deeper into libraries like Scapy for network analysis and requests for API-based security tasks. So I want to thank Cyber Nigeria trainers for providing the knowledge and tools to build real-world cybersecurity solutions. So this is it.
Okay, all right, that's fine. You are through with this part. Let's move to the question and answer session. We have 5 questions. Then each of them will carry 5 marks. How do you duplicate? How do you remove duplicates from a list?
How do you remove duplicates from a list?
Yes.
Okay, you can remove duplicate from a list by using the set function. You can convert it to a set because sets don't have duplicates, and if you convert the list to a set, it would remove all the duplicate values
Okay, all right.
elements.
What's the purpose of the pass statement?
Oh, a pass statement serves as a placeholder when a command is not really needed, but a placeholder is needed. So it basically just there, but is not necessarily executed.
Okay, all right, that's fine. How do you check if a string starts with a particular substring?
There's a function called start with. So if you had a variable with a string in it, you would say if the variable dot starts with and you input the whatever string you want. So start with is the function that you use to check whether a variable starts, I mean a string starts with something or not.
What's the difference between a set and a list?
Okay. A set does not have duplicates and a list has duplicates. That's the major difference between both of them. You can have a set with numbers like 1 1 1 appearing multiple times, but you cannot have a list. I mean, you can have a list with numbers appearing multiple times, but you cannot have a set with numbers appearing multiple times.
How do
That's
you
why if you
get
want
keys?
to
How,
remove
how, how do you
duplicates,
get
convert
keys
a
from a dictionary?
set.
How
So
do you get keys from a dictionary?
I can't hear you. You're breaking.
How do you get keys from a dictionary?
So you're
How do you
breaking.
get keys, keys, from a dictionary? Dictionary.
So
Sorry, let me write the question out for you. I'm not sure.
I couldn't hear you.
Can you look at your WhatsApp handle? How do you get keys from a dictionary? Have you seen your WhatsApp platform? Can you hear me now? How do you get keys from a dictionary? You are muted. You are muted.
Okay, sorry. You can get the keys from a dictionary by using the keys function. So you can literally just say call the name of the variable and put dot keys, and it will provide you with the keys in the dictionary. I mean the name of the dictionary, just put dot keys and it tell you the keys in the dictionary.
All right. That's all. Do you
Okay.
have any question for us?
I don't.
You can exit the platform. Next time when you're actually doing presentation, well, you're talking from the current base of your knowledge. It is how far you know now. That's actually what you're actually putting into use. So maybe when we start taking projects, you actually dive deeper and understand how things work within the cybersecurity space. You understand?
Yes, sir.
While we try to see your application of what you've learned, but they are still on the surface. Do you get it clearly? So there are way things work. So the more top notch the technology, the more in demand the product is in the market. So automation does not make decision on its own. It makes decision by comparing with the database. You understand? So they have access to tons of database they use to make intelligent decision. So anytime you click on a particular link to go to that, it's comparing the IP address with what a database it has. That's why it gives you access or quarantine, prevents you from visiting the site because it knows it's a malware site, a suspected site. So I think that's all. You can exit the platform.
Okay, sir.
Sorry, are you starting?
Okay. Good morning. So can you hear me?
I can hear you well.
Okay. I'll be doing my project defense on XE105. That is Python fundamentals. The presentation outlines as follows. I'll be explaining the importance of Python in cybersecurity. Why do cybersecurity analysts use Python? Explaining each Python concept from the Siberian arena using scenarios and use cases along with key performance indicators. Also a summary of everything, and then career path involving the use of Python in cybersecurity. Why is Python important to cybersecurity? It allows for automation and scripting. Repetitive tasks like log analysis and vulnerability scanning can be easily automated. Threat detection and analysis. Python helps in writing scripts to detect malware. Penetration testing. Many cybersecurity tools like Scapy and PyTest are built in Python for ethical hacking and security testing. Also, we have rapid prototyping. Then we have some extensive libraries and community support. Why cybersecurity analysts use Python? Python streamlines security workflows, making tasks more efficient, easy to learn, and widely used, allowing quick adoption. Python's integration with cybersecurity tools enhances investigative capabilities, and it's a must-have skill for security professionals working in automation, forensics, and penetration testing. So moving on to variable and data type labs. Here we look at a use case, log file analysis. Here we have the use case. Variables store and process log data to detect suspicious activity, e.g., failed log attempts. So here, in this code, we declare a list. We declare a list called log entry. And this log entry contains different log from the odd.log file. So this failed attempt variable here, it iterates through the list. And if the keyword failed log attempt is there, it will print suspicious failed log attempts. So here, for attempt in failed attempt, print attempt. You can see the output here. It gives us the suspicious failed login attempts as the first two in the list, while the third one is a successful login attempt. So some KPIs include the detection accuracy, percentage of suspicious events detected. We also have the processing time taken to pass log files, and we have some false positive rates, incorrectly flagged login attempts. Here we have network packet analysis as the second use case for variables. So using variables to analyze and manipulate network packets for intrusion detection. So relating to variables, we declared SR source IP as the packet.ip.src, and we declared destination IP as the packet IP.destination. Here we declare packet size as length of the packet, and then we print packets from source IP to destination IP, and also the size. So we sniff the first 5 packets. Then we run the code using sudo, and it gives this packets from source to destination and gives the size for all 4. So that's for variables.
What does this tell you? What do you derive from this sniffing of this packet? What is this telling? It's just sniffing packets. Okay, you just want to create a packet sniffer or something.
Yes, you just explain the variables and data types.
Okay, all right, that's fine. It's okay.
So moving on to the basic function labs. Okay, we have here user credential normalization and sorting. So here we have the scenario: a cybersecurity analyst collects username from employees. Since usernames should be case insensitive and stored in a sorted list, the script normalizes the inputs. That's converts to lowercase and sorts it. So some KPIs include time taken to normalize, processing speed, time taken to normalize and sort usernames, the data accuracy, the user compliance rate, and the sorting efficiency. So here, relating to basic functions, we have here username declared as an empty list. Then norm_users will convert the input function into an integer. So the function here is enter the number of usernames. So now this iterates through the norm_users. So username equals input, that's enter username. So we use the dot strip to remove white spaces, and we use the dot lower to make the string lowercase. And here we use usernames dot append to add to a list. So the list up top. And then we sort it alphabetically using the dot sort function. So now we print everything. We now print usernames. And this is what gives us enter the number of usernames, 3, enter username, we enter 3 usernames, and then we see the sorted usernames here alphabetically. That's for the first use case. Second use case, a cybersecurity analyst needs to analyze file names in a directory and detect suspicious or malicious extensions, either .exe, .bat, or .vbs. So this script converts file names to uppercase for standardization, sorts files alphabetically, and checks for dangerous file types. So some KPIs, we have the detection accuracy, the processing speed, the false positive rates, and the scalability. Here we have the script here. So based on the basic function labs, we have here uppercase_files is going to make the file variable uppercase. So .upper here. Then we have the uppercase_file.sort. It sorts the file names here, as you can see. Then we print the uppercase files, and then we iterate through the uppercase files. So if any file ends with ext, that's ext is here. So .exe, .bat, .vbs. If it ends with any of those, we print threats detected. So here we put some sample files here and we iterate through it. And there, this is output. It shows the files here, sorted files, and then it shows whether each of them is either safe or is a threat. That's for use case 2 for basic functions.
All right, that's it.
Moving on to slicing and casting, the labs. Here, we have some first use cases, extracting IP address from logs. So we extract IP from log data, and some KPIs include extraction accuracy and processing speed. In the code, we have a log entry here declared, and then we have the IP address. We want to extract the IP address from the log entry. So we use log entry.split, then split at the space. Then the fourth item here, since this is 3, counts from 0, 1 to 3. That's the third item here. And then we print it, the IP address here, as you can see. We basically sliced it from the log entry. That's for use case 1. So use case 2, extracting and converting IP address from log data for analysis. So this particular one, once we've extracted the IP address, then we convert the IP address to its 32-bit integer representation here. as you can see. We do parts. So we split the IP addresses into different parts. We iterate through it, split it into integers. So we use IP.split at the dots. We split at the dots here. So we return the integer representation, the 32-bit representation here. And then we print it IP to int. And as the output see, this is representation. So KPIs include extraction accuracy, processing speed, and memory usage. So that's all for the slicing and casting labs. Move on to the loops. So some use cases of the loops include the brute force password cracking simulation. So for the use case, we are looping through possible passwords to simulate a brute force attack. So KPIs include average time to find the password, number of guesses per second, and percentage of password cracked. So relating to the loops, here we define the brute force function, and we create a character set. For example, for this one here is ABC123. So for length in range, it rates from number 1 to 5. Then for attempts in iter2.product, so here we use the character set here, and we repeat through it. So we iterate through the character set here. And then we put the guess, we declare the guess variable as .join. So everything we've iterated through, we join everything, the attempts. And then if guess is the target password, return password cracks. So here we brute force. We use the for loop to brute force through a password here. And then we see password cracked 812. For the second use case, monitoring multiple servers for downtime using loops. So a cybersecurity analyst needs to monitor multiple servers and detect if any are unreachable. A Python script looks through a list of server IPs, pings each one, and reports downtime. So KPIs include the downtime detection rates, the response time, the false positive rates, and the scalability. So we can see we define a check server status, and then we loop through the servers. Then we use the response variable to ping each servers. And then if the response is 0, we print server is up. But if it's not 0, we print server is down. So we have a server list here, different IP addresses for servers. And then we check the server status. And then we can see in the output, this server is down. The 8.8.8.8 is up, while this other one is down. That's for loops. So moving on, sir, can you hear me?
I can hear you.
Okay. Moving on to the IO labs. We have the use case here, securely storing passwords. So we have a scenario, hashing passwords before storing them in a file. So KPIs include hashing time, storage efficiency. So here, relating to the IO, we opened the password.txt file in append mode as file. And then we write the hashed password into the file here. So then we run the code. So the code has been written into the password.txt file. Or the hashed password, rather, has been written into the .txt file. We can also use for log file analysis, reading and writing to a file to detect anomalies. KPIs include the file processing speed, the anomaly detection rate, and the storage efficiency. Here, relating to the IO, we open log file in read mode, and then we iterate through the log file. If failed login is in one of the lines, we open a suspicious logins.txt in append mode as a last file, and then we write the failed login line into the suspicious login.txt. Then we run the function here, and then we run the code. Moving on to the modules lab. We have the first scenario as using requests to check website security. So we check if a website is running HTTPS. So KPIs include the response time and the HTTPS adoption rate. Here we import the request module here, and we define check HTTPS and URL as a parameter. Then response is request.get URL. And if the response.url if it starts with HTTPS, we print secure website detected. If not, we print website is not secure. So here we check HTTPS as this example.com. See, we run the code and we see that website is not secure since the example.com website does not have HTTPS. Then we have the second use case as using OS to list system processes. So detect suspicious running process. We have the KPIs as the execution speed and the detection rate. Here we import OS, and processes is equal to os.po open. And then we use the PS auxiliary, then we use read. So we list the processes here, and we can see when we run the code, it gives us every process here. I had to cut it out due to space limitations.
Okay, but you said using OS to list process. Okay, just listing the processes.
Yes.
Well, you got a scenario detecting suspicious. So how do you detect suspicious running process? Sorry, excuse me.
So we scan through all the running processes. So any process that is out of the ordinary here in
How do you
this,
know that? How do you know that it's out of the ordinary?
like files like executables, different executables would be running.
It
So
has to
we
be
can check.
compared. It has to be compared against something. You cannot be scanning through all the file. It has to be compared against a database to actually know what is actually suspicious or not malicious, or what looks like what. Because something CV common vulnerabilities, so you can actually run that against that. So when it's okay, let's move to the next. Let's move. You get to that part next week. You get to that part next week. So it has to be run against something.
All right. So moving on to user-defined functions, the last lab here. We have a scenario here, detecting weak passwords. So this code here is to check a password strength. Here we define is weak password. If length of the password is less than 8 or not in the character set A to Z, or either not, if it does not have a here for this particular one here, it means if it does not have a digit. This one here, if it, sorry. Here means if it does not have a letter, a capital letter A to Z here. Here, if it does not have a digit, we return true. Either else we return false. So we check is weak password admin. Here returns true. Since it's a weak password, it contains neither a digit nor a uppercase letter. So the KPIs include the accuracy and the compliance rates.
Okay, all right, that's fine.
Um,
Sorry, what compliance standard did you use to actually do that?
sorry?
What compliance standard did you use to do this? Industry compliance standard? Or you just actually just put your own? It's okay, but I'm just because you talk about compliance rate. So if you are talking compliance rate, it has to actually to the industry standards of actually created by there is pass.
Okay.
So if you're actually doing any compliance, it has to come with an industry standard, a framework of an industry standard. So while the code is okay, but you mentioned compliance. Let's move on. We'll get to all those parts next week.
So here, checking suspicious file extensions. This function, this block here, blocks execution of potentially dangerous files. So we have the KPIs as the detection rate and the false positive. Here we define the function is suspicious file and the file name as the argument. So we declare dangerous extensions in a list as .exe, .bat, or .vbs, and return any file name that ends with either of these extensions. And then we print a suspicious file. Then we use an example here, virus.exe, which returns true. So, summary of the Python skills learned in cybersecurity. We start with basic functions used for data standardization, sorting, and user input handling in security applications, like username normalization and malware detection. Then we have the slicing and casting, helps extract and convert IP addresses from logs, improving log analysis and threat intelligence. And we have the loops, used in brute force attack simulations, automated network scanning, and server monitoring for detecting vulnerabilities. And we have the IO, otherwise known as file handling. It's essential for log file analysis, storing encrypted credentials, and scanning suspicious activity. We have the modules here, enables network scanning, hashing, encryption, system monitoring, and web security analysis. And we have for the user-defined function, we have custom security functions for password strength validation, suspicious file detection, and automated security checks. Then potential career paths in cybersecurity with Python. So first we have a cybersecurity analyst. We have the role here, monitoring security threats, analyzing logs, and detecting breaches. We also have a penetration tester, also known as an ethical hacker, simulates cyber attacks to find vulnerabilities. We have a digital forensics investigator, analyzing cybercrime evidence and recovering lost data. We have a malware analyst, reverse engineer malware to understand its behavior. A security engineer, develop security tools, firewalls, and intrusion detection systems. We have an SOC analyst, also known as a security operations center analyst, to detect and respond to security threats in real time. So, conclusion, Python is a powerful tool in cybersecurity due to its simplicity, automation capabilities, and extensive libraries. Whether you are interested in ethical hacking, threat analysis, or digital forensics, Python is a must-have skill for a successful cybersecurity career. Yeah, so I'm done.
Okay, just 1 minute. Then we'll go to the part where we'll ask you 5 questions. Then you actually answer them and tell us, how do you get keys from dictionary? This actually gives you 5 marks per question you answer.
We use the .keys function to get keys from a dictionary.
Okay, all right, just 1 minute. How do you check if a string starts with a specific substring?
We use the .starts with function. So a variable .starts with, and then we put the substring inside the brackets.
How do you access values in a dictionary?
Access
Values in a dictionary, values.
We use the .get function.
Dot what?
.get. The dictionary name .get.
That's how you get values.
Yes.
Okay. What's the purpose of pass statement?
It allows for execution of a code, even though basically allows for execution for future codes. So it's like a placeholder for future codes.
Pass function in a statement.
Yes. Use it as a placeholder. So if a code is not completed here, we'll put the pass. So the compiler will ignore that particular block here. There.
Are you sure of what you're saying?
Yes, sir.
Okay, how do you remove duplicates from a list?
duplicate. Think by converting it into a set, using a sets function, converting it into a set.
How do you check the type of variable in the Python?
Use the type function.
Sorry, the last calls that you got, were you guys able to check it?
The last score.
The last defense that you did, were you guys able to access your scores?
So I know my score.
You were able to actually access it from the data from the Excel sheet.
Oh, no. You already showed the score before you.
Sent out the sheet. Okay, all
Yes.
right, that's fine. I think I will share it one more time with you people together with this. I think most people were not able to actually get their scores. Okay, all right, that's fine. So that we can actually, I think what we will do is look at the stuff from the first to now so that you can see, everybody can see how they're improving.
Okay.
So your use case were more technical, but I think you are babbling in the interview questions. So do you have any question for us?
So when is the deadline to submit the project? The Siberian
Monday,
Marina project?
Monday evening.
Okay, sir.
All right,
So
that's fine. So if you are done, you can exit the platform. Let somebody else come in.
okay, sir.
Okay, sir. Good morning. My name is Zainde Taiwo, a Think Cyber Training Program cohort. For my sideways, I'm working on the project XE105, Python and cybersecurity. As we navigate the ever-evolving digital landscape, cybersecurity threats are becoming increasingly sophisticated. But what if I told you that Python, a simple yet powerful programming language, holds the key to unlocking innovative cybersecurity solutions? Join me as I dive into the fascinating world of Python and cybersecurity and discover the exciting possibilities that await us. This is XE105 Defense. Why Python for cybersecurity? First, automation. Increasing need for automation in cybersecurity tasks. 2, threat detection. Python aids in threat detection, response, and analysis. And 3, my personal motivation. I plan to use Python in my cybersecurity career because Python is basically one of the best programming languages out there, and it can be used on so many fields, in so many fields. I'm moving to our first topic. We have variables and data types. We have the real-world application, automating processes using variable assignments and data storage. Our use case, detecting malicious IP addresses, and our defensive application, we can write a script to check IPs against a known malicious IP list. Our situation, we have a situation. We need to identify and block malicious traffic from known malicious IP addresses. Our task is to develop a method to check IPs against a known malicious IP list and block the malicious traffic. Our action, we are to utilize Python to fetch a list of known malicious IP addresses from a threat intelligence field. Implemented a script to what? 1, check incoming IP addresses against the malicious IP addresses. 2, to block the traffic from the IP addresses. And 3, to log and alert on blocked traffic attempts. And our results. After we do this, we'll have successfully identified and blocked malicious traffic from known malicious IP addresses, reducing the risk of system compromise and improving incident response by 80% through automated blocking and alerting. Now we
Where is
have,
the code? Where is the
this is
code
the
for all
code.
this?
This is
Okay.
the code.
Okay, all right, that's fine.
Now this
Wait,
script,
let me see the code one more time.
okay, sir.
Okay, you fetch the malicious IP list from GitHub. Okay, all right, that's fine. Okay, all right, that's fine.
Now, this script fetches a known malicious IP list from a GitHub repository, defines a function which is malicious to check if an IP is in the malicious list, and checks a list of the IPs to check against the malicious list and prints the result. Now, here are a few keywords in variables and data types. You have integers, floats, strings, lists, dictionary, tuples, and boolean, where integers are whole numbers, floats are decimal numbers, strings are basically string of characters, list, ordered collection of items, dictionary, unordered collection of key value pairs. And we have the tuple, which is the ordered immutable collection of items, which means it cannot be changed. And lastly, we have the boolean, which we have either true or false outputs. So here I just explained what variables are. Basically, variable is a storage location that holds values. And here a data type is a classification of data based on its format, size, and set of values it can hold. We're moving on to the next topic, which is basic functions. We have the real-world application using built-in functions for log analysis. We have the incident response using built-in functions for incident response, and the use case identifying brute force attacks. So we have our situation. The system experienced an increase in failed login attempts, indicating potential brute force attacks. Our task is to develop a method to identify and detect brute force attacks in real time. The action we're going to take is we're going to use Python's pandas library to analyze system logs, identify patterns indicative of brute force attacks, implemented a script to do 1, monitor login attempts in real time, 2, track IP addresses with excessive login attempts, and 3, identify rapid succession of login attempts from same IP address. And by doing that, we'll have successfully identified and detected brute force attacks in real time, enabling prompt action to block malicious IP addresses and prevent unauthorized access, reduce risk of system compromise by 90%. So this is the script.
Let me see. You said in real time. You said in real time.
The script was basically very long.
Okay, let me see from number 1. Scroll, I don't know, because I'm seeing what you said in real time. That's actually why I want to see how it takes that in real time. Do you have somewhere you have the script?
I might have accidentally erased the script when I was taking, because I used the same script for some of the other scripts I wrote.
It's good you actually show us the real time. Okay, what's this script supposed to do?
It simulates login attempt data with usernames, IPs, and timestamps. It sets threshold for brute force detection, max attempts per minute.
I can barely look at that from here. Can you bring up that script one more time?
Let me try to search.
No, if you don't have it, we don't have that time to waste, please. You are not sure whether you have it. Can you bring up what you have? Let me see what you have in your presentation.
Okay, sir.
Okay, all right, that's fine. Because I'm seeing you setting some metrics. Okay, it's okay.
Okay, sir. I stopped at number 2. Sets threshold for brute force detection. And 3, groups login attempts by IP and username. 4, checks each group for potential brute force attempts based on the thresholds. Basic functions are basically predefined blocks of code that perform a specific task. And here are a few of them. We have print, the print function. We have the length function. You can use it to check, returns the length of a string or a list. We have the range, which generates a sequence of numbers starting from a specified start value, stopping, and also a step value. We have the min and max, used to check the minimum and maximum value from a list of values. You have sum sorted. You have sum is to basically add numbers in a list together or values in a list together. You have sorted, basically arranges lists, elements of a list in sequence. Move on to slicing and casting. Real-world application, parsing logs and extracting sensitive information. We have the use case, extracting sensitive data from logs, and defensive application, extract credit card numbers or personal identifying information from system logs. So our situation, system logs contain sensitive credit card information, posing a significant security and compliance risk. Task, extract and remove credit card numbers and info from system logs to ensure PCI DSS compliance. Our action, we are to utilize Python, Python's that's regular expression module, to parse system logs and extract credit card numbers and information. Now, our scripts, we implement our scripts towards number 1, identify and extract credit card numbers using regex patterns. 2, remove extracted credit card info from system logs. And 3, mask extracted credit card numbers for secure storage. And our results, by doing that, we'll have extracted and removed sensitive credit card information from system logs and reduce the risk of data breaches and protected customer sensitive, and we will have protected customer sensitive information. This particular code, since we I tried to find a way to actually access credit card information, but I wasn't able to, so I had to improvise.
So where is the maxed data? Because I'm seeing the full credit card number here.
I stored it in a dictionary. I studied it in a dictionary.
What's this script supposed to do? The
script basically generates random credit card information for 3 individuals and stores it in a dictionary. And the extract credit card info function takes a name as input and returns the corresponding credit card information from the dictionary.
But what I have here, can you go back to your previous script? You say you are masking, and you can see they say you are masking the credit card information in the log file, but your script is showing something different.
Basically, after you implement my script, you can use it to mask. Basically, you can use my script after you implement it, or you can basically add a script to it to mask these particular credit card information.
What are you really saying? You are confusing yourself. You've given a situation, task, action, and result. Now show us the script for this particular star. You are saying you can use this, you can use that. Where is the script for this? All right, move to the next.
Slicing is a technique used to extract a subset of elements from a sequence, such as a list or a tuple. And casting, also known as type conversion, is the process of changing data type to from one value type to another. And these are some examples of slicing and casting. You can use indexing. Basically, when you use 0, it picks the first value of whatever it is, whether it's a list or a string. You can use 0 to pick the first value. When you use -1, it picks the last value. You can use the start and stop, where it goes from here. In this particular example, we have from 1 all the way to 3. So it's going to count from 1 and then go to 2, but then it's going to leave out the third index that is there. You have this, you have until 3. So it's going to print out everything until 3. You have here 2 until. It's going to print out 2 and from the index 2 and everything after. And here it's going to print out from -3 and everything after. So we have loops. Number 1, real-world application, automating port scanning and network security analysis. 2, we have our use case, scanning for open ports. 3, defensive application. We're meant to iterate through a range of ports to check for open services. Our situation, we need to identify open services on a target system, but manual port scanning was time-consuming and inefficient. Our task is to automate port scanning to identify open services. Action, we are to utilize Python socket library to iterate through a range of ports and attempt to establish a connection. If a connection was successful, the port was mapped and the service was identified using the socket.by port function. Success after running this, we will have successfully identified open services on target systems, including HTTP, SSH, FTP, reduced manual scanning time by 90% and improve accuracy of results. So we have, this is the code right here. So
Sorry, just play that code one more time. So what are you scanning? You are scanning yourself. You are scanning your own system because I'm seeing 127.0.0.1.
Yes. This is my loopback address. I'm scanning through my system for open and closed ports.
Okay, all right, that's fine. You can actually move to the next slide.
So loops are fundamental concepts in programming that allow you to execute a block of code repeatedly for a specified number of times or until a certain condition is met. And we have a few keywords in loops. We have the for, we have the while, we have the break, continue, and range. Where for is used to iterate over a sequence, while is used to execute a block of code as long as a certain condition is true. We have the break is used to exit a loop prematurely. Continue is used to skip the current iteration of a loop and move on to the next one. And for range is used to generate a sequence of numbers for a loop. Input and output. Real-world application can securely reading and writing configuration files. Use case, managing web application configuration, and defensive application, ensuring sensitive credentials are handled properly. Sensitive credentials. Our situation, sensitive credentials such as passwords and APIs will be hard-coded or stored in plain text, posing a significant security risk. So as implement a secure method for handling sensitive credentials using inputs and outputs. Now, action, utilize Python getPass module to securely prompt users for sensitive credentials, storing them as encrypted environment variables. Implemented output masking to prevent credentials from being displayed in logs or console outputs. And our result, successfully secured sensitive credentials, reducing the risk of unauthorized access, ensured compliance with security best practices and regulatory requirements.
Sorry, can you go through that tax one more time? Can you go through the tax one more time? That's
Okay.
your star. Can you go through it one more time?
Implement a secure method for handling sensitive
Start from
credentials.
situation.
Okay, I start from situation. Sensitive credentials such as passwords and APIs are being hard-coded or stored in plain text, posing a significant security risk. So our task is to implement a secure method for handling sensitive credentials using inputs and outputs. And the action is to use the Python's getPass module to securely prompt users for sensitive credentials, storing them as encrypted environment variables.
Okay, all right. Let's see what the script does.
So the script uses the getPass library to securely get the password from the user and the hash lib library to hash the password. The hash password is stored in the config file along with the config data.
Where is that? All I'm saying is enter your password, enter your config
the
data.
password.
Config will be created successfully. Config file created successfully. So we're not seeing anything. Where is the config file? How do you demonstrate? So where's the config file?
So I'm going to show the config file. I have to launch my my Kali Linux.
Okay, all right. While you're doing that, move to the next lab. You should have that handy the next time you are doing any presentation. You see, it's moving away from basics. You are going to more mature concepts. So let's be sure you're not just copying and pasting from what's the name of this place? A ChatGPT. Let's be sure you understand what you're doing.
And here are some keywords in inputs, outputs. You have the input, used to get user input as a string. You have outputs, which is print, which is what's used to get output on the screen. You have open, which is used to open a file for reading or writing. You have the read, which is used to read contents of a file. Write to write contents of the file. And close is used to close the file after reading or writing. I have examples of using the open and read mode here. You open this file and then file.read is just going to basically open the file and show you the contents of the file. And with with the write mode, you can actually write into that particular file. And if you use the write mode the second time on that particular file, it's going to erase all the data in that particular file. So the best thing you can do is use the append mode if you want to keep all the files inside that, all the content inside that file and add more to it. Modules. Real-world application. Automating system administration tasks. 2, use case, automating system updates. And defensive application, you use Python to use Python modules to update and patch systems. So we have our situation. Manual system updates and patching are time-consuming and error-prone. Our task is to automate system updates and patching using a Python model. Now, our action is to use APT and YUM Python modules to automate updates and patching on Debian-based and RHEL-based systems. So we created a Python script to check for updates, download and install them, and apply security patches. Results achieve 100% automation, reducing manual effort by 95% and system vulnerability by 90%. And we also have a plus where we have the improved system stability and uptime through consistent updates and patches. So initially, when I ran the code, it didn't work. And that was because it didn't have permission. So I used sudo and it started to work. I used sudo and it started to work. It started to download the packages and install them. So basically, this script updates the package list, upgrades installed packages, and then cleans up any unnecessary packages or files.
Okay, all right, that's fine.
A module is a self-contained piece of code that provides a specific functionality or set of functionalities. Modules are often used to organize and structure code in a way that makes it reusable and easy to maintain. Here are some basic Python modules. We have the OS, which provides functions for interacting with the operating system. We have the sys, which offers functions for interacting with Python interpreter. You have the time, a library working with times and dates and timestamps. You have the login, a library for logging events and errors in Python applications. Then networking security, you have the sockets, the SSL, the hash life, and cryptography. Custom functions. We have the wayward application. Automating incident response procedures. Custom incident response tool. Use case, we have the custom incident response tool. And the defensive application, automate log collection and system analysis. Our situation, manual log collection and system analysis is time-consuming, prone to error, and overwhelms IT staffs, hindering efficient troubleshooting and incident response. Our task is to implement an automated log collection and system analysis solution to streamline monitoring, improve incident response, and enhance overall system reliability. Our action designed and deployed a centralized log collection system, configured automated log forwarding from various system sources, including service network devices and applications, developed custom dashboards and visualizations to facilitate real-time system analysis and anomaly detection. And our results achieve 99.9% automation of log collection, reducing manual efforts by 90%. Improved mean time to detect and mean time to resolve incidents by 75 and 60%. Enhanced system reliability and uptime through proactive monitoring and issue identification.
That's the problem with your script. We're not seeing what is very few. Some of this section now, about 3 of them, we are not seeing the effect. Can you go back, start from your situation? Let's actually follow through what this use case was supposed to do.
Manual log collection and system analysis is time-consuming, prone to errors and overwhelms IT. Hindering
Implement an automated log collection and system analysis to streamline monitoring. Okay, how do you now go to the script? What actually is automated here? How do you collect log and streamline? What does this script do?
So basically, this script collects log files from a specified directory and copies them to an output directory. Then analyzes system log files and counts the number of errors and warnings. And gets performance.
When you say what log is it logging? What is it logging? You say from a directory. What is the login?
The user log, the not only the user log, the VMware user log, the root to everything. See if I can zoom in there.
Yeah, because I'm trying to understand what this solution is, because in a typical cybersecurity center, what logs is it extracting? What information is it giving us to actually protect or know maybe the system is at risk, system is not at risk? You said login. What security information is it providing? What are the key metrics you're actually using to monitor? Those are the things you want to look into.
The var.log.
The var.log itself actually contains a lot of logs. You understand?
Yes.
If you're automatically picking, are you automatically picking information from them, or what exactly are you trying to do?
Yes, that's what I'm doing. I'm picking information from the log directory, and everything I get gets outputted into and copied into an output directory.
All right, move to the next. I'm not saying it, so that's actually one cannot make a decision, but we are not saying it. We're just
Collects
saying
log files from a specified directory and copies them
yeah,
to
it's
an
written
output.
there. It's written there, but the demonstration is actually not showing that. Do you get it?
Okay.
We're not saying the demonstration. Maybe the next time you can have a GIF, just picture how the record have the stuff so that you can actually, if you know you cannot demonstrate, you can actually have GIF showing when you demonstrated it, you just do it clearly so that we can actually see it and see the function.
Okay,
So
sir.
you can go on.
So a function is a block of code that performs a specific task, taking inputs as arguments and producing outputs, also known as return values. And the function is defined in Python using the def keyword, followed by the function name and parameters in parentheses and a colon. In conclusion, this presentation has demonstrated the real-world application of Python in cybersecurity. In cybersecurity, through the completion of 8 labs, we have explored various Python concepts and applied them to practical cybersecurity scenarios. And now the key takeaways from this presentation. 1, Python is a powerful tool for automating cybersecurity tasks and improving efficiency in security operations. 2, Python can be used for a wide range of cybersecurity applications, including threat detection, incident response, and vulnerability scanning. And continuous learning and practice are essential for mastering Python and staying up to date with the latest cybersecurity threats and technology. Also, listening to watching and reading cybersecurity news can also keep you up to date. Things happening in the cybersecurity world.
Okay, all right, that's fine. You did not do practice. You did not include practice in what you're doing. Okay, let's just quickly take this part so that we round up, then I'll tell you what I have to tell you. You have 5 questions. Out of the 5 questions, you actually you take each question take 5 marks. What's the difference between break and continuing loop?
Break prematurely exits a loop, while continue when it meets the particular condition or a specified condition, basically ignores that particular number. Let's say it's a range of numbers, and the condition is that when it gets to 3, continue. It will reach 3, skip over 3, and continue with the rest of the iterations.
What is the purpose of pass statement?
Basically, pass is a null value in Python. So when you use pass, you can use it basically for either a variable declaration or a function that you want to use later, but you don't want it to perform any actions at that point in time. So you can use the pass, so it won't give any outputs.
Okay, all right, that's fine. What's the difference between set and list?
A set basically, let me put it like this. A list can actually have duplicates, but a set can have duplicates. a
Okay, all right.
list is ordered, a set is. Okay.
How do you get the keys from a dictionary?
You can use the get keys function, or you can just print it out. Okay.
Okay, all right. How do you reverse a string in a Python?
You can use the reversed function. You can store the string in a variable and then use the reverse function on the variable and print the output.
That makes 25. We've actually 20. We've actually 5 questions. Sorry, just 1 minute. So you can stop sharing your screen. Do you have any questions for me? So next time when you're coming, don't use ChatGPT. Anything you're doing, be sure of what you're actually saying so that you don't look like a baby babbling. So this is your growth rate. You understand? Try as much as possible to be natural. You don't need to put up an accent that you are not used to. It only makes you look like a fake person. So be as real as possible. And actually, so from the first one, you scored 58, you move to 66, you move to what, 85. So be as real as possible when you are doing presentation. What you should concentrate on is the command tool technique, industry relevance. If you are stating any compliance, state what the framework and the industry body which is actually quoting the compliance. If it's actually password, weak password validation, which industry compliance are you using to actually do a weak password validation check? Do you get it?
Please, can you give me an example, sir?
Now, because something what I'm saying, it's 5. You did 7 presentations, 4 out of it you could not ascertain the function of the use case. It's not clear. It's just you're just showing off some part of a code, and the result, the output is actually, while it looks very fascinating, the project looks very fascinating, we're not seeing the output of what the project. So it's a glitch in proper communication. So if you are communicating anything, let's see what it is used for, what it's at this we are not actually looking at this is not an industry project presentation. Now, if it's an industry project presentation, it becomes the most technical project. Now, this is a defense of what you have learned. Part of what we want to see is your ability to communicate your technical capability. It's next week now, we'll be looking at industry project, the best industry project you have defended. Do you get it clearly? But at this stage, what I'm trying to look at, what we're trying to see, well mastery of Python, which most of you have demonstrated. 2, how you actually apply it to the industry, you know how to apply the function of what you're doing. Then proper communication. So somehow you have good projects, but the presentation is not showing it, and you didn't have your system ready to actually demonstrate it. Outside that, I think all what you did is wait. Let me pause this part. Sorry. 1 minute to work done.
Okay.
Okay, you can start.
All right. So my name is Oluwatfeld Banjo, and I'm one of the members of the 2025 Cyrus cohorts at Think Cyber. And here I'm going to be defending my Python knowledge. And I'm going to be explaining how Python can be used in cybersecurity and linking it with real-world applications and also showing use cases for each application. Now, the whole Python module, what we discussed and designed was how Python can be used to solve cybersecurity problems and help cybersecurity workers in industry
world. So a very, very useful thing about Python is it helps with automating tasks. So you can literally write scripts that automate tasks that would take a long time. And these scripts will just do it in real time at the response or at the click or at the call of each task that you want. And another very good thing about Python is that it is one of the most easily understandable programming languages, which is one of the functions of why the developers made it in the first place. It's one of the most easily comprehensive programming languages, and it doesn't take away from the power that it holds. So as easy and understandable as it is, it still has a big span of power and the things and functionalities that it portrays. I'm going to be going through each topic one after the other as we went through it in the Python module. The first topic is variable and data types. Now in Python, we have various types of variables such as strings, integers, list, floats, and I'm going to be touching up on a couple. But a variable is basically a placeholder identifier that holds the value of something. And we have different types of this. So you can have a string variable. This is usually denoted with inverted. This is usually denoted with apostrophes, and integers is usually numbers or things that have numbers within them. And we have lists as well. So strings, things that we can use strings for, we can use it to store passwords, URL, text logs, for security analysis, all these different type of things. And we can use integers. We can store integers as port numbers, counters, threat score, efficiency, different things that we can store integers as. Another data type that we have is list. And so this basically maintains collection of different things that you store all into one. Now, I'm going to show you the use case for each and every one at the end of it, but I basically want you to understand that variables are placeholders that store the value of something, and we can have different types. And this is very useful in cases where you need to store the value of, I don't know, maybe your port number, you need to store the value of a particular user, or you need to store the value of your list, or you need to store the value of the name that the path that your file belongs to. It is variables that you're going to use to declare and hold these things all in one. The next topic we did is essential Python functions, so basic functions. Here we dived in and discussed on different functions and how they can be applicable in real world standards. So a couple of these functions are length, upper, max, minimum, to upper, to lower, very different functions. And the thing with functions is from the name, they they carry out a particular function. So the length function now, for instance, measures strings or list lengths to verify data integrity and security logs. So let's say, for instance, you wanted to know the length of the amount of data in a particular file, you can use the length function to get that, or you wanted to know the amount of characters in a string, you can use the length function to know that. Upper, the upper function basically converts whatever you have to uppercase. So this is very, very useful in ensuring consistent alert messages. And this is a very good function for converting everything you want into uppercase so that you have the same format of everything. And when you're trying to find particular things, you're not looking for the lowercase version of it, but your file is actually in uppercase. Everything is all in the same format. Max, the max function quickly identifies highest threat scores from security teams and scan tests. Now, from my use case that I'm going to show you lower, I combined the three of these three and brought them in a way that are useful and applicable in real life, that a cybersecurity worker can write and put in a script that each of these functions come useful. Functions are basically built-in tools that accelerate data processing during incident reports. So rather than having to write one particular line of code for everything, you can call a function that just does the exact same thing, and it's a built-in tool, and it makes your job and work faster. Slicing and casting. That's the third topic we did in Python. Now, slicing and casting. Slicing is used to extract substrings and particular characters or numbers or lists or elements or items or keys, whatever it is you want. Slicing is used to extract that from its particular index. So with slicing, we have substring extraction. So you can pull specific parts from log entries using string 1:5 notation. This is a very good slicing notation. So this basically slices everything, and it gives you the things from a list from the first index to the fourth index. The fifth index is not inclusive. we have pattern sampling. So we can extract everything in an item with list N to identify patterns. So this basically just grabs everything out within the list and it shows you them in an orderly way that you can get patterns and identify patterns. And we have type conversions. This is basically casting. So you can cast an integer to a string. Let's say you had string Bolu and age 78 and you wanted to combine these two together. If you try and combine it together, it would give you an error. But with casting, you can cast either the string to an integer or cast this integer to a string that lets you combine it together. And this is basically used to normalize security inputs and help you do data accumulation in big bulks of things or with lists that come as strings. Moving on to the next topic, loop structures. So we have loops in Python. And the very, very, very best thing about loops is rather than it removes human error. Imagine you have a range of data from 1 to 1 billion. As a human being, you're not going to be able to count or check each each conclusion or check that each iteration meets your condition from 1 to 1 billion. You just physically can't. So with loops, they are also inbuilt and they find a way to read through a list of data or read through a bulk of data, and depending on the condition you write within your loop, it does that and fishes what you're looking for out for you. So we have two main essential loops in Python. We have for loops and while loops. For loops basically iterate through IP list to scan multiple endpoint efficiencies. That is one use case for a for loop. It iterates through something and scans it depending on the condition you give it. While loop, another use for while loop is it can monitor systems continuously until threats are detected or neutralized. The basic things about loops is it iterates through something or a bulk of data, and when a condition that you give the loop is met, it prints it out. And you can play around with loops. So you can break, continue. You can set a loop that once it gets what you're looking for, it ends it. It doesn't iterate to the end. There are a lot of different usefulnesses of loops. And we have nested loops. This is basically when you have a loop within a loop. So this grabs one thing from your main loop and loops it through the second thing. So you can perform multi-level analysis for complex threat hunting scenarios. This is a very good example of loops as well. Looping structures form the backbone of automated security monitoring tools. Like I said, the main efficiency of Python for cybersecurity users is it automates tasks on a day-to-day need. And loops is one of the most biggest foundation of automating things for you because it just goes through everything you want one after the other. So at the end of it all, you're still going to see my use cases. But moving on to the next topic, inputs and outputs. So for inputs and outputs, we found how to read files and write files. And another thing with this as well, you can add different functions you want while reading and writing into it. So when reading a file, you are extracting, an example of this is extracting security logs for analysis and threat detection, and you read it in the read format. And this basically, and there are different ways you can read a file. You can use the read function. This reads everything within the file. You can do read line, which just reads one particular line. You do read lines, we read everything together as a list. You can write into files as well. So you open the file and get it with the right function, with the right mode. And you can process data. This helps with applying algorithms to identify suspicious patterns. And with reading and opening files, you can set trigger alerts. So you notify teams when threats are detected. So for input and outputs, it enables analysts to process gigabytes of log data efficiently. So rather than going through a particular file and then doing it by yourself, when you mix the other things you've learned, like loops, functions, variables, when you're reading through files, you join those things together and it helps the full automation of your process or what you're trying to do much more easier. Now, a very fun topic we did was modules. Now, I just listed a couple modules. We have vast majority of modules, but a couple of the ones we did touch on in class where we have the time module. So the time module can be used to schedule security tasks and measure response times. And it can also be used to delay tasks and also get epoch time and things like that. But the main essential thing about modules is you have to import them. If you don't import them, they won't work. We have the hash sleep module. This verifies file integrity and also secures credential storage. So with the hash sleep module, you can encode and encrypt files, strings, whatever it is you're trying to do, you can encode them. And this just basically ensures that the files and your data is as integrity filled as possible. We have the OS module. This helps us to interact with system files during forensic investigations. So things like changing, making directories, writing in things. OS module, that's where that falls in. So these modules basically extend Python's capability for specialized security operations. Modules are built-in modules as well that help with getting particular things done and specializing depending on whatever you're trying to do. There's a particular module that works for that as well. Now, we have functions. So functions in Python, like any other programming language that has functions, a function from the word is something that you declare or write that does a particular thing. So you create a function, call it whatever the function is going to carry out. And within that function, you now write the different conditions, you write what you want it to do. And with functions, you can have parameters and arguments, so things that you can get and call as the function is rolling. So it just basically identifies repetitive security tasks needed during automation, and it creates reusable code blocks for specific security purposes. So you call them when needed, and you can usually use them to validate and deploy custom security functions as well. Functions enable security teams to build specialized tools for unique environments. So I want you to take a key note into that last phrase. It said it builds specialized tools for unique environments. So you can write a function for a particular thing. So if you're trying to look for malicious content, you can write a function that looks for malicious content. If you're trying to write a function that just scans IP addresses, you can write a function that just scans IP addresses. Depending on the environment in which you want it to work on, you have a function, and it just basically a list of the things you want to do, and you call it as at when needed. Now, after this, we put our hands onto some practice. And here in this practice, we did a lot of different things like testing our technical capability and the things we've learned throughout the whole Python course. And this really helped us get some really good applicable knowledge. Now, some industry applications of Python to cybersecurity users, cybersecurity workers, our penetration testers as we are, is Python actually helps with 47% faster detection. So because Python is automated, yeah, as events are happening in real time, you have already created scripts that monitor things. So it helps with faster detection with things. Python also increases your coverage by 3. So automated tools scan more systems than manual methods because they are automated. They have time to do it more vastly and more quicker. And Python helps with Python can create a 68% improved accuracy within the workspace or within the cybersecurity world because its consistent code reduces human errors in security processes. Python skills have become very essential for modern SOC analysts, penetration testers, and incident responders because all these are industries in which automation has to be done because things are happening in real time. Data packets are getting sent in real time. Things have to be read. Things have to be automated to read this in real time. And Python helps and ensuring that all these things are accurate. Now, this is the end of my presentation. I'm going to take us into my use cases and the code I wrote for each of these topics. I'm just loading my Kali. Okay, I'm going to share my screen now. Can you see my screen?
It's coming up. I've not seen it yet. Okay, it's
Okay,
okay.
it's up. Okay. Now, for my variables, this is a very good use case. So this is a code that opens things. So it opens this auth.log file and it reads it. So for each line that is in this code, that is in this data, if it finds the word field in line after I've converted everything to lower, it prints alert.script, prints the line in which the field is at. For basic functions now, here, remember how I use the len function and I use the upper function. So this is a function that converts everything in my log file, converts everything to my log file into upper cases, and it also gives me the length of it. So if we run this code here, right here, run this code. As you can see, everything has been converted to upper cases, and they also gave me the length of it, which is right here. This is the length of it. So this is a very good example in which functions and inbuilt functions in Python help with automation. So here, slicing and casting. Here, I created a list that has 4 elements: Bolu, John, Doe, 12. And I created a variable, and this variable gets the first index within this list. And I created an integer to cast the third element within this list to an integer, because as you can see here within the original list, it is a string, but I'm casting it as an integer. So when I print split data, you will see that it will give me Bolu and it will print the type of this integer data. So I run this. This is a use case in which
Hello, can we please move to the question and answer session? I've seen all your demonstrations so that we don't waste time.
okay, that's fine. Should I stop sharing my screen?
You can stop sharing your screen. How do you reverse a string in Python? There are 5 questions. You actually will answer
Okay.
5. How do you reverse a string in Python?
So to reverse a string in Python, the fastest way to do that is using the reverse function. So you have your list and you put the dot reverse and it just
How do you
reverses everything.
get the keys from a dictionary?
You use the get key function. So my date, the name of your dictionary, then dot get keys, and you print keys.
What is the difference between set and list?
So a set cannot have repetitive numbers. So let's say, for instance, the number 1 comes up 5 times in a list. You won't see that within a set. A list is ordered, but it has repetitive values. But a set is not ordered, but it doesn't have repetitive values.
How do you access values in a dictionary?
Use the get value function. So my dict get values.
Okay, just one more, then we're done. What is the purpose of the pass statement?
Purpose of a pass statement is it does not return any particular thing, but it is used in a situation where you're trying to execute code and you're later going to need the things you executed in further calculations. So it doesn't return any particular thing, but it stores those things that it has executed before, and when you're going to call them for more calculation. So for
Um,
instance, now
okay, continue.
for instance, now, let's say you are looping through something. You have your sum, you have your average, and you create a pass in which you you create a pass for the sum. So you're not printing out the sum directly, but it's still going to save the value of that your sum. But when you're not getting your sum, to get an average, you need sum over length. So when you're getting the average, you're just going to call what is saved before within the sum. So it will get you the value of your average.
How do you remove duplicates from a list?
You use the set function.
So I think that's all. You have a problem with actually displaying your use case. You must be very articulate when you display your use case. You're not actually demonstrating your use case very well. That was very poor demonstration of your use case compared to what others did. You're not very articulate in demonstrating your use case. But for now, we have to stop here till 4 p.m. So
Okay.
I will share your results with you just now on the platform so that you can see what you've been doing from the first presentation up until now.
All
So I
right.
think the purpose of this particular stuff has been achieved. I've read everybody, but you just need to move from where you are. So that's it on the platform from XE101 to XE105. Just one person left. So
Okay.
I've read everybody's performing over 70. That looks like a good performance. So do you have any question for me?
No.
You can start.
Okay, sir. Hello, everyone. My name is Awodun Elijah, and I'll be demonstrating how my XE105 Python skills directly apply to real-world cybersecurity scenarios. We will explore practical examples showcasing Python's automating threat detection, incident response, and vulnerability analysis, preparing me for careers in cybersecurity. So why Python for cybersecurity? First, for automation need, there is increasing need for automation and scripting in cybersecurity, and Python is just the best option for such. Two, threat management. Python helps in threat detection, response, and analysis workflows. Also, it gives us a boost on how to use Python in our cybersecurity career. First, we looked at variables and data types. A real-world application of such topic is for storing and comparing users' credentials for anomaly detection. The use cases, we have a script here to compare a user's login attempt against a whitelist of approved usernames. And a defense application, this script flags unauthorized login attempt using a whitelist. So right here, we see a function, a little Python code here is approved users equals to this list. Then login attempt is equals to David as a string. So if login attempt not in unapproved users, in approved users, print alert, unauthorized login attempt detected. So what this little code does for us here is it checks if login attempt is in David. And if it is not in David, it prints unauthorized login attempt detected. Number two, basic functions. A real-world application of it is counting occurrences of specific keywords in phishing emails. A use case is in identifying brute force attacks by extracting IPs from authentication logs. A defensive application is one, this in which it counts suspicious keywords to spot phishing emails. So we have a little code right here. It says email content is equals to this list right here. So keyword count is equals to sum, one for line in email content, if urgent in line.lower. So if there's an urgent keyword in that line in email content, it adds one to it. So when you print it, it gets the number of times there is that word urgent in email content so that you can get the spot phishing emails, because phishing emails might come as urgent, click this. So as you can see here on the code, when run, it says suspicious keyword urgent detected twice. So this is what basic functions can do. It can give us the ability to get phishing emails. So this now tells me that, okay, there's an email that has the word urgent in it, and how many times? Twice. So we have slicing and casting. A real world application for this is extracting timestamps from network traffic logs. An use case is pass timestamps from logs to identify unusual activity patterns. And this extracts timestamps to detect odd network activity. So we have this particular code here. We have a variable named log.line, which is equals to this string. And a timestamp uses the ability of slicing to get a particular line, to get a particular word from that particular variable up there. So you can see it extracts the 19th from the first to the 19th variable right there. As you can see, when printed, it gives us the connections timestamp, and it gives us this particular, the timestamp, which will date your time, your month, and your day. Loops. A real world application is for checking multiple files for malware signatures. And a use case is loops through directory to compare file hashes against malware data. And this scans files for malware using hash comparison. So we have this module here, we imported hashlib. Then we got a particular hash. Then we hashed this particular hello. We got the MD5 hash of it. Then we now compare using this print statement if this data is the same as this malware hash. So this data was hashed, and we compared
Sorry, what use case? This particular loop, what use case is this? Because it's just a string you are encoding and comparing with the malware hash. You are just, it's not a proper use case. Look through a directory to compare files against a malware data. In this page, you're not comparing a file, you're only comparing a string. I hope you get what I'm trying to say. So anything
Yes,
you
sir.
actually, if it's a use case, it should be a use case that can be used within the industry, not just a simple. If you are demonstrating an example, what you did is an example, not a use case. I hope you understand. Now you're actually exiting level 1. So anything you're doing should actually align with the standard in the industry, a proper industry solution. Do you get it clearly?
Yes, sir.
Good. So that's what you should be doing. Okay, you can continue.
Okay, so upon comparing the hash of hello and the malware hash that we originally have, you can print the malware detected because they both align. So 5, we have input output. So what this does is it's a real world application of it. It logs security alerts to a file for all these purposes. And the use case is write logged failed login attempts to a log file for later review. So in the industry, when you can do it overnight, then when you wake up in the morning, you go and check, you see a lot of login attempts which has been saved to a file, which input and output can use, which output can be used for. And the defensive application is this logs failed SSH attempts for auditing. So we have right here, alert is equals to an example of what this can do. Alert is equals to this string. Then with open security alert.txt, which is the file which you already have. Then file.write alert. This alert in is a new line. So you write this alert that we have into this particular file. Then with open security alert, which is the alert file that you have, you can now print recent alerts as the contents of security alert. So right here, you can see it was added to it. And the output gives failed SSH login from the IP address at this time. So this is a particular example of this. So modules is next. So a defensive application of modules is it resolves domains to IPs for threat checking. The use case is this is the socket model to resolve domain names and check against the block list. And it automates DNS lookups for threat intelligence. So right here, we imported this module, which is socket, and we said domain is equals to Google domain, and socket dot guest host by name, which is we're able to do because of imported the module. So what to get the host by name of this domain here, and it prints out the IP for the domain. And right here, we can see it has been carried out, and it gives us the result IP address for google.com, and it gives an IP address. So this is an importance of modules as a topic, because without which we can't get that function, which is guest host by name. So right here is the final one, custom functions. And a robot application is validating file integrity using forensic analysis. And we created a custom function to compute and compare file hashes. And this verifies file integrity with hash comparison. But a simple example right here we can use function for is we can define a function, check password. Then if password is equals to secret, return access granted. Return access denied if it does not equal secret. So then we printed after we called the function. So this is a very simple use case of custom functions. We can see right here, it printed access granted as the final answer when it has run through that particular function. So all these labs I've gone through is a summary of what we've done in XE105.
You did not include you did not include practice. Okay, it's okay. If you do not include practice, okay. Okay, all right. Let's actually take your questions from the scenarios. Just 1 minute. How do you remove duplicates from a list?
So first off, removing duplicates from a list, we can convert it to a set, because a set only allows unique values, not allow duplicates. So when you convert it to a set, it removes all the duplicates. Then you convert it back to a list, and you're back to where you were once. So you convert it to a set and convert it back.
How do you access values in a dictionary?
So you use dictionary.values. Is a function, is an inbuilt function that we use to get the values in the dictionary. Dot values.
How do you convert a list of string to a single string?
So you use the dot join function. So you say you use a double quote, which is empty, dot join. Then you put what you want to add together. So you dot join, you put the string of content that you want to join, then you print it out, then it comes as join and as one.
How do you get keys from dictionary?
So you use the function dot keys. When you say dictionary, you call the dictionary, then you put dot keys, then you put open brackets and close brackets. So when you use the dot keys function, it returns all the keys in the dictionary.
How do you reverse a string in Python?
So the way to reverse a string, you use double column then -1. When you use such, it reverses the content.
Okay, all right, that's fine. Just 1 minute. You are not sounding so confident like the way you were sounding the last time. Okay, just that you look more calm and reserved on this presentation. Is there any reason for that?